I, Neha Samundre, Assistant Professor, Department of Computer Science, feel extremely privileged and honored to be given this opportunity to welcome you all here in this August gathering. It's a matter of great pleasure that the Department of Computer Science and Application of Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts has organized this conference on a very relevant topic in the present context entitled Technological Advancement in Computer Science, Artificial Intelligence, Machine Learning and Data Science, which holds a greater significance in the present day's educational system. Science and technology are marching fast worldwide, and every day there are new technologies and advancing technologies as far as teaching and learnings are concerned. We have to ensure the use of the newer and newer technology to make pedagogy more and more effective. Technologies are technologies like artificial intelligence, learning management system, augmented and virtual reality, gamification and blockchain are playing the key role in the field of education today. We can use them in multiple ways in graded structure. While the terms data science, artificial intelligence, and machine learning fall in the same domain and are connected, they have specific applications and meanings. There may be overlaps in these domains now and then, but each of these three terms has unique uses. These technologies are not only useful in academic growth, but also in every field of life. In the data economy, data is king. Today, any business, small, medium, or large, thrives on its data sets. The relevant trend of offering data-driven insights as a service has opened up a profitable revenue channel for businesses. Cloud computing and hosted analytics have brought data as a service to the desktop of ordinary business users, which was unheard of even a few years ago. As the global business environment is fasting moving toward all things digital, artificial intelligence, machine learning, and deep learning will play as important roles as data science is reshaping business across the world. This conference will highlight the connections between data science, machine learning, and artificial intelligence. The evolution of data science and machine learning in the age of artificial intelligence has been marked by significant advancement in technology and computing power. Data science, which involves extracting insights from larger sets of structured and unstructured data, has become a crucial component of modern business operations. As artificial intelligence continues to evolve, data science and machine learning will likely become even more crucial for businesses looking to stay competitive in any increasingly complex digital landscape. Data science, machine learning, and artificial intelligence are increasingly used to improve decision making and gain a competitive edge. Understanding the difference between data science and machine learning and artificial intelligence is crucial in today's digital world. Data science is the process of extracting insights and knowledge from data using statistical and computational techniques. It involves collecting, processing, analyzing, and interpreting large data sets to derive meaningful information. On the other hand, machine learning is a subset of AI that focuses on building algorithms that can learn from data and predictions and make predictions or decisions without being explicitly programmed to do so. It uses statistical models to identify patterns in data and improve its performance over time. We are all aware that the more technologies we use, the more effective, more interesting, and more easier becomes the process of teaching and learning. This conference aims at acquainting the teachers and students with the recent advancements in computer science and information technology. I extend a warm welcome to our chief guest, respected Dr. Ravinder Singh, former director and the Honorable Professor, Punjab University Regional Centre, Ludhiana. The chairperson of this conference, Dr. S. C. Gulhane, the secretary of Prerna Seva Mandal, Chief Executive Officer, Ms. Abhilasha Gurde, the director of Dr. S. C. Gulhane, Prerna College of Commerce, Science and Arts, Dr. Praveen Joshi, the officiating principal, Dr. Leeladhar Revatkar, our keynote speaker, Dr. P. L. Chitra, Professor and Head, Department of Computer Science, University of Madras, Chennai, and all my dear friends. At this juncture, we are delighted to have with us distinguished personalities who will grace this occasion with their insights and wisdom. Without further ado, let's begin with the inaugural proceedings. I request Dr. Praveen Joshi to present an introductory remark. Over to you, sir.
Good morning, everybody. I extend a warm welcome to all the delegates, the chief guest at the inaugural, Dr. Ravinder Singh, my younger brother, my friend. He is a scholar, he is a researcher, he is an educationist, he is a thinker, and above all, he is a great human being. It's great pleasure and I feel privileged that he has accepted our invitation and he has joined us today online for the inauguration of this conference. Beside me is my elder brother, my dearest friend, Dr. C. Gulhane, the Honorable Secretary of Prerna Seva Mandal, the CEO of Prerna Seva Mandal, Ms. Abhilasha Gurde, Principal Dr. Revatkar, Neha Samundre, the faculty of Dr. S. C. Gulhane, Prerna College of Commerce, Science and Arts, and all those participants who have joined from different distant places across the country. It's a very relevant topic that the Department of Computer Science has chosen for this conference. It holds great relevance, especially when technologically we are advancing very fast. At present, whatever technology we have, during last 10 years, whatever progress we have made, that was not made during last 50 years. The pace of the progress, technological progress, has grown that fast. Now, as Neha Samundre has rightly said, that this is the age of AI. Earlier, it was the age of certain religions. Religions used to guide us. At different times, we used to seek solutions from our religious text. We used to get inspiration from the lives of great people. But now the time has come that AI, artificial intelligence, is there. And it is going to play a revolutionary role in the lives of human beings. Now, recently, on 30th November 2022, chat bot, we call it Chat GPT. Chat is the chatting machine through which we can chat, and there is GPT, generative pre-trained transformation. Now, what will happen? It can do anything for you. What Netflix did in 3 years, what Google has done about in 10 months, what Microsoft took about 6 months to do, this chat GPT has done only in 5 days. As soon as it was launched, within 5 days, it had 10 lakh people on it. And 10 lakh, having 10 lakh people joining it is not a small thing. So the GPT has taken the whole world by storm. The professionals like doctor, architects, engineers, CA, all professions are being threatened. They have that apprehension in mind that if chat GPT is there, their professional services will be endangered. It has such a vast data with it, and it has that fast calculative power and ability that within seconds you get the solution to your problems. If you have a business problem, you just talk to the chat GPT, and within seconds it will give you the solution. If you have some kind of physical problem, you did not go to doctor. You just tell all the symptoms to chat GPT, and immediately your diagnosis will be done, and even the medicine will be prescribed. You ask any question to it, and the answer will be immediately available, and that's also in conversational style. Google is doing for last 10 years. Google has not made any kind of revolutionary changes. Still, suppose you type a word on Google, for example, Islam or Hindu. So all the articles, all the chapters, all the books which are available on Google will come on a screen. It will not give you something that is very specific that you require. But chat GPT will give you the exact answer. Exact answer. Suppose you are facing your fridge is not working. What problem is there? You just tell it to your chat GPT and the answer will be there. Even the smallest thing, how to make tea, it will get the answer. Married girls, newly married girls can take help of chat GPT. Suppose they want to make some kind of dish. So step by step, everything will be there, and that too in dialogue form. It will work as a guide. You have to build a house. You give the area. So many designs will come there according to your area. What FSI is there, how much you can avail, how much space you have to live around your house. And then in the prescribed norms, you will get so many designs of your house. And then architectural guidance, engineering guidance, and everything. Even it will calculate how much expenditure you will require for constructing any building. You will get all the rates that you require. How much, if you describe the quality of the land there, how deep the foundation should go, that also will be there. it will do wonders. It will do wonders. As far as income tax calculations are concerned, you have to file returns. You need not go to CA. You give everything to Chat GPT, and how much tax you have to pay, how much refund you will get, everything will be done. CA will not be required. Imagine that particular period. Elon Musk says now, after 2 years, you will find everywhere Chat GPT. They are going to produce cars which will use AI, and that will be the safest cars in the world. There will be driverless cars, but still, once you give the direction, it will take you to your destination. It will follow your oral instructions. Stop. So it will stop. And not suddenly. It will properly maneuver itself to a proper place. And suppose on the way you say stop, it will not stop. It will give you instructions back that this is not the place where we can stop. It will take some time. This about space research and every kind of research you can get a lot of help. Suppose I am asked to write an essay on something. You just give the topic and you will get the essay composed on it. Suppose I have to write some poem for my beloved, for my girlfriend, and if that kind of poem is not available, what I have to say, I would put it into prose form and the poem will be before you in seconds. But my concern is that whether AI or Chat GPT will challenge the human creativity. In colleges, we give projects to our students. And if Chat GPT is available, they will give the project to it and the project will be ready. They will not apply their mind. Poets will use Chat GPT for composing poems. They will not apply their mind. Even today, some poets, what they do, they look for the rhyming words. Which word matches this particular word in order to make the poem a rhythmic one. AI or GPT, they are going to bring about a revolution in the world. But at the same time, what will happen with human beings? Medical science says the part of your body that is not useful in the present times, your body will lose it. Appendix, earlier we used to eat raw food. But then we started eating cooked food. So that appendix is not necessary. So even if it is removed, your body will have no effect. Will that time come when you don't have to use brain? What will happen with human brain? Will it lose its ability? Will it lose its creativity? Will you lose its innovative power? Will man lose his thinking capacity? Because if everything is given to AI or GPT, you don't have to think. You will not apply your mind. So ideas will not rise. In this way, it is very much possible that it will reduce, lower, and affect the human creativity. the innovative mind of human beings. Friends, it's true that every innovation, every invention is good for human beings, but at the same time, it can be misused. Even the thief will thief will find out any information about you, where you are, and if you are taking a house. Criminals can use AI and chat GPT for their own purpose. Terrorists can do it. So when we make any invention, when we make scientific development, it has got its negative side also. I think in this conference, machine learning, AI, chat GPT, and deep learning, and everything that is related to this field will be elaborately discussed, and hope that something positive comes out of this conference. Once again, I welcome all of you and thank you for giving me this opportunity to share my views with all of you. Thank you very much.
Thank you very much, sir, for your enthusiastic remark. As it is said, well beginning is half done, and this introductory start has set the tone of this conference. Thank you so much, sir. Friends, it is a matter of great pride and privilege to introduce our chief guest to all of you, Dr. Ravinder Singh. He is a professor of finance, University Business School, Ludhiana. He is a great scholar, academician, researcher, and educationist, and above all, a great teacher who has not confined himself only to the acquisition of knowledge only from the basic field of his studies, but also he has studied from other branches of knowledge and pedagogy. Excuse me. His thirst for knowledge is overpowering, and he makes all possible efforts to quench his knowledge thirst by reading and more reading. He is a voracious reader and mostly is submerged in his books. Earlier, he had been director of Regional Center of Punjab University. He has enjoyed many important positions in a number of universities. He was a member of Board of Studies and researcher, Haryana School of Business, Guru Nanak Dev University, and Uttarakhand State Open University, and a Senate member of Punjab University, Chandigarh. His achievements are numerous, and the list is very long. He was also on the advisory council member of GHG Institute of Law located in Ludhiana. He has also adorned the position of member of Standing Committee of College Development Council at Punjab University, Chandigarh, member of the Faculty of Business Management and Commerce of the same university. He has vast administrative experience, as well as he had been the principal constituent college of Punjab University, located at Faryal, as well as one more college at Moga. Dear all, as I have said earlier, his achievements as an eminent academician are very impressive and very inspiring. Mention of all of his achievements in such a short time period is not really possible. A student of Khalsa College, Amritsar, and Guru Nanak Dev University, Amritsar, Professor Ravinder Singh sir has brought many laurels to his alma mater. Having guided a number of research students, our chief guest has achieved the distinction of having supervised more than 100 research projects during his tenure as a professor. We are lucky to have such a learned academician and researcher as our chief guest for the inauguration of today's conference. I On behalf of our institution, extends a warm welcome to him. I would like to thank you, sir, for taking the time off your tight schedule and marking this morning wonderful for all of us with your august presence. Now, on behalf of Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts, I, Neha Samundre, request Dr. Ravinder Singh, sir, kindly to enlighten us with his erudite address and inaugurate this conference. Sir,
Yes, thanks a lot, ma'am, for the wonderful introduction.
thank you so much.
First of all, good morning to all present. And before I start with my, talk, I would like to extend my thanks to the, dynamic director of this college, Dr. Praveen Joshi. I keep on watching him, on the Facebook, and the kind of effort he's putting in for the development of the college, and to provide the quality education to the students. I feel that is really appreciable. The kind of efforts his team is putting under his able leadership, I think this college has done a lot of contribution for the growth of the society, for the growth of these students. And I see that in near future, this college will have a very good name, uh, in the country. And as in the beginning, Dr. Praveen was saying that this is not my field. And after listening to Dr. Praveen Joshi, his address, it was really enlightening. And in case a person from the field of literature, a person who is actually specializing in the field of language, can talk so much about this AI. So I feel that no one from us can say that or should say that we, this is not our field. It was really enlightening. I think after listening to him, there's no need of any other person talking anything about AI. It was so comprehensive, so knowledgeable. He covered each and every aspect of this, AI, which is, actually emerging field in front of us. He talked about the benefits. He talked about the, repercussions which this AI will be having on the society. But since I have been given this task to speak on this topic for 10 minutes, I think I I should perform my duty as well. I would like to give some presentation. I would take just 1 second to share the presentation with all of you. Just 1 second. Yes, I think the presentation is visible.
Yes, sir.
Okay,
Yeah, now it is visible.
just a minute. I will have to adjust it. It's not moving actually. Yes, is it visible, the presentation? Yes, ma'am.
No, sir, now it's not.
Yes, ma'am. But is it visible now?
Yes, sir, it is visible, but it is in minimization mode. Yeah, you
Okay, just
can.
a minute.
Yeah.
Is it okay now?
Yes, sir.
Is it legible?
Yes, sir. Yes, sir.
Yes. Thanks a lot. Sorry, it took some time.
No, no issue, sir.
Okay, so we are talking about AI, machine learning, and big data. These are the buzzwords, and everybody is talking about these, new innovations which are coming, and which the human, being will be confronting with, or already confronting right now. You know, this world has seen changes coming in, and change we know is the only constant here. When we talk about AI, it is the fourth industrial revolution which we say is coming up. And it is basically the use of technology for the betterment of the humankind. And in case we look back into the first industrial revolution, we look back into the second, third revolution. When those revolutions came in, there were a lot of apprehensions. And at each stage, we were feeling that the machines, the technology will be replacing the human being. But in case we look back, we have seen that the technology has always been helpful to the mankind. It has helped us in the improvement of the living standards of the people. It has helped us economically, and there has been, I feel, positive impact of all these on the social issues as well. And since this AI is emerging up, it is actually going to bring in, as Dr. Praveen Joshi was saying, phenomenal change in the society. In case we talk about the earlier three revolutions, they impacted actually one or two or three segments of the society. But as already said, this AI is going to bring in phenomenal change in the society. It will not be restricted, the impact of this AI will not be restricted to one or two segments of the society. Rather, almost all the segments of the society, social as well as economic, will be getting impacted because of this AI. I was just collecting the list of the sectors which will be getting affected because of this AI. So I found that almost all the industrial segments, societal segments, they will be feeling the change because of the AI coming in. Be it food technology, be it logistics and transportation, be it healthcare, manufacturing, information technology, legal businesses, travel, real estate, fashion, hospitality, education. Everywhere you will feel that this AI is going to make a lot of transformation. And it's not only this, that the various industrial segments or societal segments will be getting changed, but even the way we fight wars, they will be also getting changed. We all already know that the drones, they are taking place of the fighter planes. So everything will be witnessing huge change. And you know this is, we all know that change is the only constant here in this world. But the most surprising is the rate at which the change is coming in. Earlier, in case something was changing, after 1 year, after 2 years, now it is changing within, few hours. Everything has become instant. And because of this AI, the things will further change. Till now, the AI it was there already. It was already there. But the general public, they were not aware how much revolution this AI can bring in which areas this AI is being used. But it is just like a plane moving on the runway and is ready to take off. Till now, AI was running on the runway like the plane, but now it is ready to take off. It is going to take huge jump, and soon, within 2-3 years, we all are going to witness huge change in our surroundings, in our way of living, in the products we are consuming, in the services we are taking or we are rendering. Everything starting from healthcare, education, banking has already seen a huge change. Everything is going to witness a phenomenal change. So I have collected some data with respect to what AI is doing in the economies so far as its economic contribution is concerned. Just have a look onto this graph. AI market size worldwide in 2021 and from there to 2030, from just over over $2 billion. The size of this market is expected to increase to around $2 trillion by 2030. The size of our Indian economy is $3.4 trillion. And this AI will be contributing at the global level, will be having a market share of $2 trillion. Then just a look at the investments being made by the prominent countries in the world in the development of AI. Till 2021, or you can say 2020, not much of the investments were being made for the development of AI. But look at the graph. Starting 2020, there's a huge jump, particularly from countries like US and China, which they are making into the development of AI models, AI technology. And you can see the gray line is representing the investment made at the global level by all the countries together in the growth of artificial intelligence. When such is the kind of investment being made in AI, in the development of AI, so we cannot hold any debate whether we need AI or we do not need AI. It is going to be there. Now the only issue is that how to ride this wave of innovation. In case we look back, industrial revolutions, those countries, whenever any change come, it is human psyche that we criticize it on one account or the other. But then those who actually lead the innovation, they reap the benefit, and the other human beings or the industries or the countries which keep on criticizing, they are left behind. This is what we have learned. So AI is already in, huge investments is being made. So we will have to just ensure it that we do not miss this wave of revolution. Otherwise, we'll be, we will go behind, we will lag behind, and we will, become economically and, socially backward. So this we cannot afford. So we have to, just make ourselves aware that, this AI is going to bring in big change in the society, and just ensure that we actually make use of this AI, and actually we either lead it, this new wave of change, new wave of innovation, or become at least a part of this, so that we can make our keep our society, our country relevant for the rest of the world. This is the share of AI in the GDP. So China is expected to be at number one so far as the use of AI is concerned. No doubt it is US which is making huge investment in the development of AI models. But as per the data available from the authentic resources, the contribution of AI industry in the GDP of China will be 26 point, it will be more than 26%. Then followed by some other countries. Then in case we look into India, I could not collect the data from the sources, but there was one news which was telling that the contribution of AI in the Indian GDP will be around 20 to 25%. It was as per the announcement made by IT Minister Chandrasekhar, Government of India. So we are also expected to play a big role in the growth of artificial intelligence. This is how the productivity change when some new innovation comes in. When the innovation of electricity was put in place, the productivity of the amount we are investing and the labor productivity, they jumped up significantly in the beginning, in the initial years of the introduction of this innovation of electricity, but then it stabilized around 2% with respect to the labor market. The productivity of labor market increased by 2% because of the introduction of electricity, and that of the manufacturing industry went up by more than 1%. So whenever innovation come in, so we have seen that it leads to increase in productivity, it leads to increase in efficiency, and that further leads to improvement in the standard of living of the people. And this information technology, It is, I have taken it from the Goldman Sachs report, wherein they say that because of the introduction of IT, the productivity went up. You can see the graph, the productivity of the labor and the productivity of the manufacturing industry because of the introduction of IT. And it was, very high in the beginning, and then it settled around 1%. We witnessed 1% growth in the labor productivity because of the information technology, use of the information technology, and more than 2.5% increase in productivity because of the use of IT in IT in the investment part. This is about how the various countries will be getting benefited with respect to their productivity because of the use of AI. This data I have taken from Statista, which is again one of the very authentic sources. So the maximum benefit of the use of AI will be to Sweden, 37% increase in the productivity because of the use of AI by 2035, followed by US, Japan, Austria, Germany, UK. And I was just checking into how much increase in productivity India will witness because of this use of new technology, artificial intelligence. So as per one of the estimates, the GDP of India will go up by $1 trillion because of the use of artificial intelligence. And then, measured in terms of percentage, the sources, they give different information. In some sources, they have stated that use of AI will lead to 1.4% increase in GDP of India. And in some other sources, they have stated that India will witness 1.7% increase in GDP because of the use of AI. So we can say that AI will lead to increase in productivity of the country, from a range of 1.4 to 1.7%. And this is again some information with respect to the use of AI, the productivity and the efficiency. You can see in the graph that labor productivity improvements are expected to account for over 55% all GDP gains. So whatever GDP gains will get from artificial intelligence, from the use of artificial intelligence, 55% in that will be the contribution of artificial intelligence. So artificial intelligence will help us in improving the productivity as well as in improving the efficiency. Then moving further, this is some data with respect to the largest artificial intelligence companies, largest on the basis of market capitalization. You can see that at number one comes Microsoft, followed by Alphabet, then Nvidia, then some other companies, Tesla, and so on. That list is there. The market capitalization of the Microsoft is more than 2.5 trillion. Then comes Alphabet, wherein the market capitalization is more than $1.6 trillion. Such large companies with huge market cap, they are working on the development of this field, artificial intelligence. Combine these two companies, which are at number one and two, they're larger in size than the size of whole of our country. Our GDP is 3.4 trillion US dollars. In case we sum up the market cap of these two companies is more than $4 trillion. You can easily imagine the size of this AI industry is having in the world. So only two companies. Rest of the companies, in case we ignore them, means in case we include them also, then you can see the efforts being put in by the corporate world for the development of artificial intelligence. I was just collecting the data with respect to the innovation in the field of AI. So out of the total patents filed across the world with respect to AI, China filed 4,636 applications for the grant of AI related patents, and this is 65%, almost 65% of the total patents filed by China. 65% of that, they are just related to grant of patents related to AI. So AI is the innovation where is the where most of the efforts are being put in. Then US, they have filed almost 20% of the patents filed by them, by the US, they are related to AI. In case we look into India, we are lagging a bit behind. Out of the total patents filed by us, it is 3.4% only which are related to artificial intelligence. But India is doing wonderfully well. We started late, but there's a huge jump. In the coming data, you can see that we are improving upon in a significant manner rapidly so far as use and this development of AI is concerned. So this is some information about the patents filed by various companies across the world related to artificial intelligence. So LG Electronics comes at number one, followed by some other companies. So lot of efforts are going in for the for the innovations related to the field of artificial intelligence. Almost every kind of industry, be it healthcare, be it electronics, be it IT, be it food technology, be it real estate, everybody, every company in this sector is trying to make use of this artificial intelligence. So far as India is concerned, I was just saying that there's a huge jump with respect to the patents we are filing for the related to this artificial intelligence. In 2017-18, the percentage of AI related patents in the total patents filed by India was just 1.3%, and you can see there's a huge jump. From 1.3%, it went up to 6.1% of the total patents filed. So it is increasing significantly. The sectors wherein we are filing the applications for the grant of patents in the sectors, healthcare comes at number one, and this sector is witnessing huge growth also. You can see it's a trend starting 2018 to 2022, followed by image processing, transportation, ed tech means education, then IoT based automation, then fintech. So we are our country is trying to do better in these sectors so far as the use of artificial intelligence is concerned. And from this data, we can see that it is the healthcare industry which will be witnessing huge transformation in their way of working, as Dr. Joshi was also sharing, because of the developments of AI coming in this field. And then transportation, image processing, followed by education. We being the educationists, academicians, we are also going to witness this transformation in a big way. And for us, the challenge will be really big because of this AI transformation. I'll be talking about this in the coming few slides. The kind of education we are providing to our students is going to see a sea change, and we will have to change ourselves. We will have to transform our syllabus, our methodology of teaching. Only then we can ride on this wave of artificial intelligence. We'll talk about this in detail in the coming slides. This is the ranking of our country with respect to the use and the development of artificial intelligence. This is, I hope you are able to see on AI ranking, the score of United States of America is 100 out of 100, and we scored 31 out of 100. And then the important point for us is the source of happiness for us is we are ranked at 32nd position in the world so far as the use and development of AI is concerned, ranked at 32nd position in the world. But important here is that in 2022 we were ranked at 32nd, but 1 year ago in 2021 we were ranked at 51st position. So there's a huge jump of 19 ranks. It's a significant jump with respect to use and development of AI. Within 1 year we jumped 19 ranks upwards. So that's good for us. So this is some information with respect to the investment in artificial intelligence. This information I am not sharing the amount, just the size of this circle is telling to us about the quantum of investment being made by various countries across the world in artificial intelligence. From the size of the circle, you can make it out that China comes at number one, followed by Hong Kong, then comes United States of America, then Belgium, then Japan. India is of course there. We are also there in this list, but we are making much less contribution, much less investment. But there has been significant jump in the last 2-3 years in the AI related activities, research and development activities over the last 3-4 years, which we have made. Then it is businesses reporting using artificial intelligence. So businesses which are making use of the artificial intelligence, they do report also about this to the society. I collected this data from the sources, and you can see that Denmark is leading in this. They are the country in the world wherein most number of businesses are reporting to the society that we are making use of the artificial intelligence. Then some other countries are there, but India is not figuring here because our businesses, they are not reporting much about the use of artificial intelligence they are making. Then this is the number of companies involved in the use and in the development of artificial intelligence. In the United States of America, the number of companies is more than 17,000, which are working on the development and use of artificial intelligence. Then countries like China is there, Germany is there. In India, we have more than 2,500 companies which are working on this aspect, artificial intelligence and development. This is number of artificial intelligence companies per capita. We do not figure here anywhere because we are a huge country, 144 crore people. Though we have making investment in this growth and development of AI, but per capita we are on a very low side. So that's why India is not figuring over here. Singapore, Israel, Estonia, these are the countries which are leading so far as per capita artificial intelligence companies are concerned. And then this funding of artificial intelligence companies. The United States of America in the year 2020 invested $3 billion in the artificial intelligence companies. Then China $1 billion, and India invested $0.5 billion. And this is very important because whenever we think of the benefit of any innovation, of using any innovation, so we think about the benefit we'll be drawing out of it. So this slide is sharing with us the information with respect to increase in GDPI in terms of percentage, as well as in terms of the currency value in the GDP of any country. Like China will be witnessing huge change, huge growth in their GDP. The contribution of AI in their GDP will be 26.1%, which will be equal to almost $7 trillion. Then followed by North America, 14.5%. Then North Europe will be more than 9%. Then you can see it is Southern Europe, 11.5%. Latin America, more than 5%. Rest of the world, 5.8%. About India, I have already told to you, by 2035, we will be witnessing around $1 trillion increase in the GDP of our country because of the use of AI. And in terms of percentage, it will be between 1.4 to 1.7%. So everybody is getting benefited out of it because of the use of AI. But the major issue is, as Dr. Praveen was also sharing during his address, we are scared of artificial intelligence because we feel that most of the jobs will be eaten away. In country like us, wherein the size of population is 144 crore people, wherein the major chunk of the population, almost 70%, is into the working age group. In case AI is going to take away the jobs like this, where will our youth get employed? There can be unrest in the society. But I was looking into the data, and in case we look back also, look back into the revolutions, industrial revolutions we have experienced till now. Initially, it was the replacement of manual production with the machine-made production. Then second industrial revolution came in with respect to the use of energy. Then came in computerization and digitalization, when this computerization and this digitalization innovation started in. People started talking about it. The first thing they were talking about that unemployment, the effect of that on employment opportunities. It was discussed. It was the perception or apprehension, I'll say, that the computers will take away jobs. There'll be a lot of unemployment. But in case we look back into the history, the number of jobs because of these revolutions actually has gone up. So technology, along with bringing in or helping us in improving the standard of living of the people, has also increased the employment opportunities. The only thing is, the only thing is that the kind of jobs which we have right now, maybe these jobs will not be there, but new kind of jobs will be there. So this is what, this I have taken from the World Economic Forum. This data, the World Economic Forum concluded in October 2020 that while AI would likely take away 85 million jobs globally by 2025, it would also generate 97 million new jobs in fields ranging from big data, machine learning to information security and digital marketing. So 85 million jobs will be taken away, but more than that, means 12 million more jobs will be in place because of the new technology coming in. So different people have given, different views. They have conducted research on this. There's one research conducted by author in 2015, presented evidence that the labor market has become polarized over the last few decades towards low skilled and high skilled jobs, and away from medium skilled jobs due to the advent of computers and AI. So what this author is talking about, the middle level jobs will be taken away, but the low level jobs and the senior level jobs will still be there, and their number will go up. Arnett et al. 2016, they argue that instead of substitution, transformation is more likely to occur, with 35% of jobs would change radically in the next 2 decades. So it will not be substitution. This Arnett and his colleagues in their search stated that replacement will not be there, substitution will not be there, but transformation will be there. Means the nature of the job will change, but the number of jobs needed, the number of employees needed will still be there, and maybe it will be more than what is needed. I was just collecting some more data. Like we have got various industries, banking is there, insurance is there, and some other sectors, transportation, reality sector, they are there. How much of their work can be automated through the use of artificial intelligence? This purple color shows the work which can be automated, use of the artificial intelligence. Then this green part shows us that percentage of the work in a particular industry which can be performed, which will be performed by human beings but will be assisted by the artificial intelligence. Then red color is that part of the jobs which are which can be automated, but their chances of getting automated are very less because of the cost benefit analysis. And then this gray part is that part which will not be automated at all. And you can see that there is still significant part in various industries wherein automation will not will touch upon any particular job. Okay, starting with banking, the major change will be witnessed by the banking industry because of this AI. And this is very important. This is another source I have taken. This is another report of World Economic Reform. They say this, in this report, this World Economic Reform stated that because of this, artificial intelligence coming in their earlier report, they have stated that 85 million jobs will be taken away and 97 million jobs will be created. But in their new report in 2020, they stated that, in fact, because of the artificial intelligence, we will be in need of 133 million new employees and will be losing 75 million jobs in the areas of data entry clerks, accounting, bookkeeping, pay clerks, administrative and executive secretaries, assembly and factory workers. These are the areas which will become irrelevant because of this AI coming in. The top 10 emerging areas is data analyst, scientist, AI and machine learning specialist, then journal and operational managers, software and application developers and analysts. So these are the emerging areas. So this is what I was talking about. This education sector will see a huge change because many professions will become irrelevant. Dr. Praveen Joshi was talking about the filing of the this return, income tax return. You will not be in need of a chartered accountant anymore. Okay, this the softwares will be working for you. Accounting part is already taken away. Income tax will be taken away. Inventory management, because of the systems like ERP, enterprise resource planning, they are also already all taken away. So means there are areas which will become redundant in the very near future. So we will have to see what kind of education we need to provide to our students so that they remain employable. So this is top 10 emerging areas wherein we need to train our students. our young generation for. And then these are another 10 areas which have become, which are going or have become almost irrelevant, and we need to see whether this kind of education is needed or not. And then these top 10 skills of 2025. So these are the skills which are needed: analytical thinking and innovation, active learning and learning strategies, complex problem solving, critical thinking and analysis. So these are the kind of skills we need to train our students in. And unfortunately, I'm not sure about the kind of education we are running there in Maharashtra, but in case we see into northern India, in most of the educational institutions, we are not training or equipping our students with these kind of skills. So we need to change everything. Everything I'm saying, because we have not changed since quite a long time, particularly the syllabi, they are the method, the pedagogy of our teaching. And whenever we as a teacher teach to our students, there's one objective we want to achieve. Right now, in most part of our education institution, most part of our country, the major mission is that our students should be highest possible marks. We are not working on their, on the development of their thought process. All these skills they will get equipped with only in case we are able to develop their thought process. So we have to change, total transformation in the education sector. So this is which sectors have hired the most during the last 6-7 years. In 2022, you can see it is, internet, then comes in software companies, hardware companies. The major kind of employment is happening in these kind of companies only: IT, pharma, banking, and financial services. So these are the sectors which are giving employment to the people. So we have to train our students according to this. The model of education focus on development of thought process means the total landscape of the industry, of the society is changing and will further change because of the coming in of artificial intelligence. So instead of making our students just number minting machines, as a teacher, we should focus on the development of their thought process. Only then we can think of they becoming critical thinkers. Herein, I will talk about the national education policy also, in case you have gone through it, NEP 2020. So this NEP 2020 is talking about the open book examination. Open book examination means student will be able to attempt the question paper only in case his thought process is developed. Right? So I feel that whatever kind of environment is merging because of the coming in of this artificial intelligence, to make ourselves relevant, to make our youth competent to perform their duties in that environment, we need to work on their thought process. And NEP 2020, I feel, is exactly designed for achieving that objective. So this artificial intelligence is going to bring in phenomenal change. There's no question about that. There's no need there. I feel the discussion on this, whether AI is needed or not, is not relevant. The issue before us is that how to become the leaders in this field, and how to transform our society, our education sector, because education sector is the one which will be developing the youth for the coming generations, for the coming challenges. And I think as the educationist, we are required to perform major role here. So let us hope that this AI will help in the social as well as economic development of the society. With these words, thanks a lot to all of you. I hope this was a bit useful for the participants.
Absolutely, sir.
Yes.
Very comprehensive, very exhaustive, very informative, educative, and everything has been covered.
Thanks a lot, sir, for the kind words. But yours presentation was also wonderful. It was really wonderful.
Thank you so much, sir. It is true that change is the only thing which is constant. We all have to be aware about the changes and the use of this technology called AI. Thank you very much, sir, for your enlightening interesting, informative, and mesmerizing address that has marked the inaugural of the conference. Listening to you is really an enriching experience for all of us. In your address, you have elaboratively dwelled on very important aspect of recent advances in computer science and information technology. We shall always cherish your valuable views that you have so wonderfully expressed on this occasion. Thank you so much, sir. Once again, thank you. Now, I would like to introduce our esteemed chairperson of today's event, Dr. S. C. Gulhane, the Secretary of Prerna Seva Mandal. Sir is a distinguished figure in the field of education, known for his exceptional contribution toward the towards the education of the society. His commitment to educate each and every individual of the society has made a lasting impact on our community. We are privileged to have Dr. S. C. Gulhane with us today to share his thoughts and insights. So now, I would like to request Dr. S. C. Gulhane sir to enlighten all of us.
नमस्कार सभी को। आज के प्रमुख अतिथि प्रोफेसर रवि इंदर सिंह सर, जो पंजाब यूनिवर्सिटी के जाने माने प्रोफेसर है, डॉक्टर प्रवीण जोशी, जो मेरे छोटे भाई है और हमारा 45 साल का बहुत पुराना मित्रत्व है, जो अभी सिंह साहब ने बोला कि उनके मार्गदर्शन में कॉलेज बहुत स्पीडली डेवलप होगा। हमने पिछले 3 साल में सर, हम यूनिवर्सिटी में टॉप कॉलेज एक गिना जाता है। वो सर ने मेरे मित्र प्रवीण जोशी और मेरी बेटी अभिलाषा, ये दोनों इतने जॉइंट एफर्ट करते हैं कि मेरी जरूरत ही नहीं गिरती। इसलिए डबल इंजन सरकार के टाइप डबल इंजन कॉलेज डेवलपमेंट है। और रियली सर में हमारा मित्रत्व तो बहुत अलग प्रकार का है, और उन्होंने जिस स्पीड से कॉलेज को यूनिवर्सिटी के टॉप पर पहुंचाया, ये रियली कि उनकी तारीफ करने के लिए मेरे पास शब्द है नहीं। तो सर, आपने बराबर पहचाना कि प्रवीण जोशी सर के अंडर कैसा कॉलेज आगे बढ़ेगा। सीईओ मेरी बेटी अभिलाषा गुर्दे, प्रिंसिपल डॉक्टर रेवतकर सर, मैं कंप्यूटर साइंस विभाग को बधाई देता हूं कि एक अति महत्वपूर्ण विषय पर उन्होंने इस कॉन्फ्रेंस का आयोजन किया है। मैं उन सभी लोगों को बधाई देता हूं जो देश के अन्य राज्यों से ऑनलाइन जुड़े हैं। हम सभी जानते हैं कि आज इस वैज्ञानिक विश्व में बिना कंप्यूटर के कार्य करना एक असंभव सा हो गया है। शिक्षा क्षेत्र में तो बिना कंप्यूटर कार्य करना आज एक असंभव बात हुई है। कंप्यूटर विज्ञान ने सारे विश्व में एक क्रांति लाई है एवं सारे विश्व को आपस में जोड़ दिया है। साथ में संसार को एक तरह से परिवार बना दिया है। आज हम तकनीक के माध्यम से कोई भी कार्य सहजता से साथ पार कर सकते हैं। इंटरनेट में तो सारे विश्व को जोड़कर ज्ञान का विस्तार बढ़ाया है एवं विचारों के आदान प्रदान में महत्वपूर्ण भूमिका निभाई है। रोबोट तथा कृत्रिम बुद्धिमत्ता के विकसित होकर मानव समाज के कार्य का बोझ हल्का किया है। साथ में शिक्षा क्षेत्र में क्रांति लाकर शिक्षा के आदान प्रदान को अति मनोरंजक, परिणामकारक एवं आसान बना दिया है। मुझे उम्मीद है कि कॉन्फ्रेंस के द्वारा विज्ञान में होने वाले अधिक संशोधन को एक नई दिशा मिलेगी। पुनः एक बार सभी को बधाई देते हुए मैं अपने 2 शब्द समाप्त करता हूं और सिंह सर को एक बार फिर नमस्कार करता हूं।
Thank you so much, sir, for the words of encouragement and for your valuable time. Friends, Expressing gratitude to our guests remains a pleasure as well as duty, for which I, Neha Samundri, hand over the proceedings to Ms. Priyanka Chandawar and take your leave. Thank you very much. Have a nice day. Thank you.
Thank you, Gulani sir, for chairing the session.
Thank you so much, Neha madam. It is with immense gratitude and sincere appreciation that I, Priyanka Chandawar, from Department of Computer Science, on behalf of Dr. S.C. Gulane, Prerna College of Commerce, Science and Arts, is here before you to extend a heartfelt vote of thanks to our esteemed chief guest. This day has been enriched by his insightful words, profound knowledge, and inspiring thoughts. Our honorable chief guest, Dr. Ravinder Singh, presence here has been a true privilege. His address not only illuminated the topic of the conference at the hand, but also opened the doors to new perspectives and ideas. We are fortunate to have been recipients of his expertise and wisdom. Thank you once again, sir, for an enlightening and inspiring inaugural address. Your contribution will undoubtedly resonate with us for a long time to come. I also thank respected Dr. Asigulani sir, chairperson of inaugural function, for their continuous motivation and guidance. Thank you so much, Abhilasha Madam, CEO of Prerna Seva Mandal, for your gracious presence. I'm thankful to Dr. Praveen Joshi, Director of Dr. S.C. Gullane, Prerna College of Commerce, Science and Art. Sir, your insightful words at the beginning of this inaugural function have set the frame of the event. Thank you so much, sir. I thank all the distinguished participants across the country for their enthusiastic participation in this conference. Thank you very much for being with us. And now we are heading towards our first session, and for that, I would like to hand over the charge to Shivani ma'am. So, friends, now I, Priyanka Chandawar, take your leave and next over to Shivani ma'am. Thank you.
Sir, thank you very much.
Thanks a lot. It was a nice experience listening to you.
It was a wonderful experience listening to you.
Thank you, sir.
Thank you. Thank you.
I'll take leave now. Thank you.
Am I audible, sir?
Yes.
Audible, madam.
Shall I start?
Yeah, you can.
Sent.
Thank you so much, Priyanka ma'am. A very good morning to all the dignitaries, principal, head of all the departments and faculty members. I, Shivani Mesawat, Assistant Professor from the Department of Computer Science, extend a warm and hearty welcome to all on behalf of Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts in two-day interdisciplinary national conference on technological advancement in computer science, artificial intelligence, machine learning, and data science, organized by the Department of Computer Science and Application. As we all know that, in simple words, artificial intelligence refers to the development of intelligent machine that can perform tasks that usually require human intelligence. Some examples include visual perception, speech recognition, decision making, and language translation. Now, I have the honor of introducing our special guest for today, a person of outstanding personality, Honorable Keynote Speaker Dr. P.L. Chitra, ma'am, with us. Ma'am will Ji, ma'am. Welcome, ma'am. Ma'am will keep us inspired during the entire session on deep learning models for 3D medical image processing. Dr. P.L. Chitra is the head in charge in the Department of Network Security and Information Technology and professor in the Department of Computer Science at the University of Madras. She has more than 32 years of experience in teaching. She has been serving as organizing chair and program committees of several international conferences. PhD and MPhil research supervisor for guiding image processing techniques, big data analytics, medical image processing, deep learning models, and network security. She has published more than 133 papers in national and international journal with 213 citations. It's a true honor to have someone with such a dynamic personality with us today. And I'm sure everybody is excited to listen our today's distinguished guest. Now I request Dr. P.L. Chitra ma'am to please enlighten us with your talk. Over to you, ma'am.
So good morning, everyone, and happy morning to everyone.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Yeah, I'm happy to take part in this national conference on technological advancements in computer science, artificial intelligence, machine learning, and data science, organized by the Department of Computer Science of Dr. A.C. Gulhan Prerna College of Commerce, Science, Arts, Nagpur. I have listened to your inauguration session, and I have noted that our eminent speakers of the introductory speech, followed by introduction speech and inaugural address, our professors have nicely brought about what is all about AI and what is the status of AI in global and national level impact have been clearly discussed. So with this, I would like to take part and give some insight onto the deep learning models for 3D medical image processing. Before that, it is my primary duty to thank the organizers for having given me the opportunity to speak and interact with this eminent forum for the next 45 to 60 minutes. Special thanks to our professor, Dr. Liladar, for having given me this chance and to interact with you. Thank you, sir, and thank you. And with this, I will present my session. I'm just sharing my screen. Yeah. Is it visible and am I audible?
Yes, ma'am.
Yeah.
Visible and audible.
So thank you once again, and let us start with our session. So the aim of this session is to give insights onto the deep learning models for 3D medical image processing. The agenda of this session is to focus on what is digital image, medical image processing, healthcare with AI, deep learning in medical image processing. So let me give some small basics about what is a digital image, how image analysis could be carried out in the medical and healthcare field. So let us talk about a digital image, which is a representation of two-dimensional image as a finite set of digital values called picture elements or pixels. So this is a scene element. Here elimination energy is required. When the elimination is incident on the scene, through the imaging system, we can get the image. So the output is given in the screen. So this is a scene element which has been projected over here. Each grid with a small square is called as a picture element, which is being placed on the screen. So pixel values typically represent gray levels, colors, heights, opacities, etc. When you have 2D image, we have x-axis and y-axis. When we have 3D image, we have x-axis, y-axis along with height. So this is a small image object element. This is a digitization of the given object element. And this is another medical image, X-ray image. And this is a small 1 pixel which is noted here in this particular picture. So normally in image processing, we have to select the problem domain and we have to go with image acquisition. That is whether we are going to apply to our medical images, either in the form of CT images or MRI images or ultrasonic images. So we have to find the modality.
Excuse me, ma'am.
We will get some information. Then image enhancement. So image enhancement, we need to do some pre-processing.
Ma'am, PPT is not moving, ma'am.
PPT is not moving?
Yes, ma'am.
Yeah, please. I'll do. 1 second. Is it visible now?
Yes, ma'am. It is
Yeah.
visible.
So we have knowledge base. So problem domain, image acquisition. The next stage is called as image enhancement, removing noise. Unwanted noise could be removed with the help of image enhancement stage. Then image restoration. This is the extension of the image enhancement. It could also be helpful for smoothing and sharpening of the given image by introducing mathematical models. Then we have color image processing. Some applications we need to work with color images directly, and we can do processing directly with color images. In the color image, we have 3 channels: red channel, green channel, and blue channel. Then followed by when you want to work with wavelets and multi-resolution processing, that could be done with frequency domain. So when we work with pixels directly, it is called a spatial domain. When we work with directly with some transformation in the frequency domain, after that we can do some filtering and other applications through which we may be able to achieve some useful image processing techniques. So for that, one such example is wavelet. This is one of the frequency domain function, and multi-resolution processing. Then compression, when you reduce, for example, if you want to transfer the information from source to destination in the age of multimedia, we are just transferring images, videos. For that, we require some zip file, RAR file. So we can go with text compression, multimedia, basically image compression, video compression. So all these things will come under this section. Then followed by, we can also extend with morphological processing, segmentation. Morphological processing is nothing but just we have to apply some dilation and erosion functions through which we may able to achieve something for some useful purposes. Followed by, in the medical image analysis, when we handle medical images, it is essential to take out the region of interest. Region of interest is nothing but extracted with the help of the process known as segmentation. So through thresholding method, it is possible to extract the information through segmentation, since we have to take over the segmentation part in the medical image analysis. Then representation and description in certain applications in graphics modeling, when we want to represent some geometrical shapes or when you want to make use of it, this could be coming under representation and description. Then followed by, as our beginning, our professor pointed out, autonomous vehicles, right, without drivers. In that, it is essential to recognize the objects in front of the vehicle when driverless car is on. So for that purpose, this type of application is essential. Object recognition, pattern recognition, some feature extraction that could be done through this application. So for everything, we need knowledge base. Through the knowledge base, after taking the image modality, we may able to work with this and outputs of these steps of generally image attributes. So normally we have low-level processing, high-level processing, and middle-level processing. In the low-level processing, standard procedures are applied to improve image quality procedures, which is not at all required any intelligent capabilities. That is coming under low level. Input is image, output is also processed image. That is coming under low-level processing. Intermediate level processing, extract and characterize components in the image. For example, some intelligent capabilities are required. For example, segmentation, and we need to extract and we have to apply some algorithms through which we may be able to come out with some attributes out of the given image. In the high-level processing, recognition, interpretation. So here in high-level processing, computer vision applications, artificial intelligence applications, all these things are coming up under this level. Procedures require high intelligent capabilities. As of now, we have only von Neumann architecture, which can understand only binary language in the form of zeros and ones. But in the artificial intelligence, we are applying some intelligent algorithms, that is some meaningful algorithms with knowledge base, and based on the decision making, it is possible to make the system to react like a intelligent system. For that, we are applying machine learning techniques, and different neural networks are available. Then deep learning models are available to automate the processes. Let us look into this in detail in this session. Block diagram of cancer images using image processing techniques have been depicted in this particular slide. So you need to require some cancer images as input. Then pre-processing, we can do some, for example, when you want to resize or when you want to remove some background, meaningless background, all these things could be done with respect to this pre-processing. Then followed outlier removal. Then followed by, we need to remove the noise. Noise is nothing but an unwanted signal. So the unwanted signal could be disturbances could be removed by either by means of smoothing, low pass filters or high pass filters. Let me give some introductory about all these techniques, how it works. Then followed by, we'll get into the deep learning model, and also we'll differentiate what is a 2D and what is a 3D, how it works in medical image processing. So segmentation, as I have already mentioned, region of interest. For example, in this particular diagram, when you take this image, here this is a region of portion. Whether this portion is cancerous or non-cancerous, that could be analyzed after extracting the region of interest. Then followed by, we have lot of benchmark data sets available. For example, PRATS 2012, then 18, 19, 20. It's going on with challenges, and people are taking up a meaningful data sets with the forum. So they are using some labeling techniques. The labeling techniques can be done with the help of annotation tool. With this, we are just introducing pre-processing using medical images. So when you have a grayscale images like 0 to 255 with pixel intensities, it could be given in the range of 0.0 to 1.0. The pre-processing is improving image data by means of removing unwanted noise in order to enhance the images. The image processing techniques are normally in enhancement, smoothing, and sharpening. Smoothing means highlighting that is by blur the image. Then sharpening is nothing but highlighting the edges. Image pre-processing techniques used are normally scaling, transformation, zooming, resizing, and converting images to grayscale images. This is a small mammogram image in which the black and white image is being taken, then followed by the region of interest is identified to identify whether the cells are malignant or benign. So with this small example is given in this diagram. Enhancement is essential for highlighting interesting detail in images, specifically in X-ray images like this, due to low radiation, because high radiation is harmful to the health of the mankind. Therefore, it is essential to give the low radiation through which we may be able to obtain the picture only by this quality. This could be improved with the help of removing noise from the given image, either by means of smoothing and sharpening. We may be able to achieve this data after processing as one of the filter applied. We may be able to come out with this. Then this is highlighting interesting detail in the images for further diagnosis by the physicians. Then removing noise from image. Here, as you see in this image, here it is disturbance. That is, while taking the X-ray, it has been involved with some salt and pepper noise. That could be due to poor radiation with poor resolution. This would have been happened after taking this picture. This has to be improved by blurring, or if you want, you can also highlight the details. So this is the essential pre-processing technique which could be applied to any pre-processing, any image processing applications. So this is another type of image enhancement for highlighting, sharpening effect. Take slice from MRI scan of the canine heart of the dog. This is the original MRI image of a dog heart. So we image with gray levels representing tissue density. These are all tissue densities. Use a suitable filter to highlight edges. The aim of this particular left-hand side input image has been converted, and it just extracts only the region of interest with the help of the filter. So this edge detection images could be done. This is another part of the sharpening effect. So while doing all this, we require this small mathematical functions, which is really helpful to play around the matrix. Our image is nothing but a two-dimensional finite data, set of data. That is, we have m rows and n columns. Suppose the given image size is 256 rows, 256 columns. We have to work with that 256 rows and 256 image pixels with intensities. So it may be the grayscale image or it may be the color image. Normally color image could be transformed into grayscale since it does have only one channel, right? That is 0 to 255, 256 rows, 256 columns. That much of pixels will be available. So it is essential to pre-process, and also we need to do certain processing to produce our output. The histogram of an image shows us the distribution of gray levels in the image. How much gray levels and how many times it is present. That has been shown in this histogram. This is a pictorial representation of the given image with respect to pixels. So this is another mathematical function. We have learned a lot of mathematical functions right from our fifth standard onwards, like mean, median, everything, then filters, then average, then standard deviation, distributions, Gaussian distribution, normal, that is called as normal distribution, then probability. Then all these functions are having a vital meaning, and this could be taken meaningfully, and we can apply to our input image as a 2D matrix, then we can come out with lot of processing. So for that, to distribution of the gray levels could be identified with the help of pictorial representation of histogram. After getting the histogram, if you have a low contrast image, that could be converted into high contrast image by equalizing the gray levels. For that purpose, this particular formula is required, and this we have already learned, and we are just applying. What is this T? T is nothing but a transformation. RK is the input intensity of the given input image. SK is nothing but a processed intensity, that is going to be our output pixels. Then what is T? The transformation function which we are going to use is nothing but summation of J is equal to 1 to K. For every pixel, we are going to find the probability of that intensity. What is RJ? RJ is nothing but input intensity, right? So for that, the formula is NJ. What is NJ? The particular intensity divided by total number of elements. For every J is equal to 1 to K. So if you apply this formula, then what we can do is we can distribute. That is, we can equalize the gray level. So with this formula, spreading out the frequencies in an image is a simple way to improve dark or washed out image to the highlighted high contrast image. So I think this is clear to everyone. SK is equal to T of RK. So what is RK? Input intensity. PR of RJ is nothing but the given sigma is nothing but summation of, for all the intensities from 1 to K, this has to be calculated. So this could be said that Nj by N. What is Nj? The frequency of intensity J divided by the sum of all frequencies. If you do this, you will get the spreading out the frequencies in the given input image. So I think it's clear to everyone. If you have any doubts, you can stop me and let us have the clarifications. Let us make it as an interactive session. So this is an example. Original image, then dark image, so then equalized image. If you see the equalized image, the data has been based on the above formula, this has been just distributed towards. So if you see the input image, original image, then equalized image, then a selection of images and their histograms have been shown in this diagram. Notice that relationship between the images and their histograms have been given. Low contrast image will be like a low pass filter. High contrast images, the pixels will be in a high contrast portion. Then we have high contrast image has the most evenly spaced histogram. So we can understand the distribution of gray levels in the given image with the help of histogram equalization. So dark images, light images, low contrast images, high contrast image. When you have some dark images, it is not clear, right? So that could be applied with histogram equalization. Similarly, when we have some very bright images, that could also be adjusted with histogram equalization to distribute the gray levels throughout the image from 0 to 255 in order to process clearly. For this purpose, this particular information has been given in this slide. So the another important processing which could be applied to our 2D matrix is nothing but our image, right? Negative. What is this? This is a mammogram image. Here tissue density is given as an original image. So when you want to identify the abnormality of the cells in this mammogram image, like this portion, we can apply negative of this image. How do we find the negative? We need to have a small matrix. That matrix is nothing but our input image. For example, this matrix consists of, assume, 0 to 256 rows and columns. So then based on this, if you apply for every pixel from for I1 to M, for I1 to N, you just find out 1.0. What is 1.0? That is the maximum resolution. So maximum resolution of this particular input image has been 1.0 minus every pixel intensity. If you apply this formula for 0, 0 pixel to M minus 1, N minus 1 pixel, then we will be getting this negative image. after getting the negative image, it's a reverse of the given image. Here, this portion is being clearly identified, and this has been shown over here. Based on that, the analyst can identify whether it's a malignant or non-malignant, whether it's a affected cell or whether it's a normal cell. That could be done. So for this simple processing technique, which is required is nothing but negative. So negative images are useful for enhancing white or gray detail embedded in dark regions of image. Note how much clearer the tissue in the negative image of the mammogram below. So this type of applications are required in the medical image processing. These are all coming 2D domain. This could be extended to 3D with the help of the modalities. When you take MRI, it could be in the form of DICOM. DICOM is in the 3D form. That could be applied with some deep learning models to some process. That's what our aim is to focus on for the next few minutes. So this is another important processing technique in image processing, thresholding. This has to be applied in our image processing. Thresholding transformations are particularly useful for segmentation, in which we want to isolate an object of interest from a background. For example, this portion, when you have a original image of a bone cancer is being displayed as an input image, after identifying the threshold value, maybe for example 85 or something like that, if we just compare every pixel with greater than that 85 value, if it is greater than 85, make it 1, otherwise make it 0. So final output would be in the form of binary. So the grayscale image is being converted into zeros and ones only with the region of interest. The background must be 0 value as an intensity value. Therefore, it has not been affected. Since it remains 0, the only portion, this particular original image bone cancer has been converted into binary with details. So these are all pre-processing techniques, and based on thresholding only, region of interest could be isolated or extracted from the given input image. This is one of the very interesting and important processing in medical image processing domain. So another important mathematical function, as we know, logarithmic transformations. So log functions are particularly useful when the input grade level values may have an extremely large range of values. As you know, large values, the input, when the input grade level values may have an extremely large values, that could be mapped within the range. For that purpose, logarithmic transformation, it is normally useful for outlier detection, and it could be removed outlier things from the given foreground image. So the general form of the log transformation, as you know, S is a processed intensity. These are all coming under point by point processing. C is the constant, which is now 1 into log of 1 plus R. R is the input intensity. If you apply this function, it maps a narrow range of low input gray level values into a wider range of output values. So this is small example. Kidney, then this has been shown with kidney cancer, and this could be applied with log transformation, and if you do the inverse log transformation, you will get the opposite transformation. So Fourier transformation could also be applied followed by that. Then we have another type of thing is called as power law transformation. This is another simple mathematical function, power function. As we know in mathematics, we have learned everything from schooling itself. So based on this R to the power gamma. S, what is S? S is nothing but output intensity. C is a constant which is equal to 1 here. R is the input intensity to the power gamma. With the help of that, when R is equal to 1, it's a straight line, right? It doesn't make any sense if both are identical function. Map a narrow range of dark input values into a wider range of output values, or vice versa, by varying gamma values, and which will give different types of inputs. So once if you apply, you will get these transformations. So this is gamma 1, this is gamma 1.5, 2.5, 3.0, 10.0, 25, this side. Similarly, that side we can go with some small values, 0.40, 0.20, 0.10, 0.04. So it depends on that input intensity versus output intensity. We can have the mapping, and we can have some transformations. Let us see some useful applications with this. This is another simple example of uterus cancer. So you see the transformation with gamma to the power, gamma is equal to 0.6 with the input intensity R, which is shown here. So you can see the difference from this input image to input image about the tissue density, and based on that, shells nature could be, textures could be analyzed, then followed by 0.3. 0.3 is giving dull version of this, 0.4 is giving another version of this, 0.6 is performing better. So depends on that, we may be able to apply power law transformation to the input matrix with assume this is maybe 512 rows and 512 columns. This matrix, this input image could be transformed with color. So this is the color image. This could be transformed with gamma. So the images to the right show real cancer image of a fractured human woman uterus. This is a uterus portion. So different curves highlight different detail here. With gamma, very 0.6 shows here like this. 0.3 if you apply, you will get this output. 0.4 is applied as a gamma. This output is received. So this type of processing is called as image analysis. This type of things will go on with image processing. So with this, when you take any medical imaging, it is called as, it is meant for medical imaging purposes. Image intensities can be radiation, absorption in X-ray imaging, acoustic pressure in ultrasound, radio frequency signal amplitude in MRI. I hope this is clear to everyone. And with this, we can find different modalities, X-rays, MRI, CT, then spectral images. All these things will help us to analyze the internal organs of the body of the mankind. So based on the human tissues and other things, medical imaging processing could be done. So dimensionality refers to whether a segmentation method operates in a 2D image domain or a 3D image domain. If you have only X and Y axis, it is coming under 2D image domain. If you have X, Y along with depth, it is called as Z along with depth. That is called as a depth. Opacities, it is called as 3D image domain. Generally, 2D methods are applied to 2D images and 3D methods are applied to 3D images. Let us see about the difference also in near future. So in some cases, however, 2D methods are applied sequentially to the slices of a 3D image. 3D image could be converted into 2D slices. Then based on the slices, it could be applied for easy implementation. This may arise because of practical reasons, ease of implementation, lower computational complexity, reduced memory requirements. When we talk about 3D, it is a huge matrix. That has to be stored properly and it has to be involved. So major modalities, as I have already mentioned, X-ray based on radiography, then computer tomography, CT, magnetic resonance imaging, MRI, ultrasound. This is a ultrasound image. As you know, pregnant ladies can watch it. So CT is not the best choice for that. For example, in the case of MRI scan shows tendons and ligaments very well. Tumor in the brain is better seen on MRI than CT. So some simple comparison is given. So when CT shows organ tear or organ injury quickly and efficiently for the damaged organs or torn in accident. So this type of cases, modality of the particular image could be CT. So depends on the requirement. Our physicians will go recommend for CT scan or MRI scan for the patient. MRI's injury to the spinal cord, for that scenario, CT scan would be better. So based on that only, we will be getting medical imaging. So normally, all this imaging will be in the form of DICOM or NIFTY. So based on that, we can work on it. So we have seen what is a medical image, what is an image, what are the different types of processing we can avail, then what are the different stages of images. All these things could be applied to our medical image processing. Medical imaging is the technique and process of creating visual representation of the interior of a body for clinical analysis and medical intervention, as well as visual representation of the function of some organs or tissues. As you know, medical diagnosis consists of consultation, information obtained from the patient as a image format. Then physical examination by the physician, inspection, measurements, all these things. Then followed by medical test recommended by the physicians. So from the medical test, As an image analyst, we may contribute ourselves with laboratory analysis, biosignal analysis, for example, ECG, EEGs for heart cases, then image analysis. So this image analysis is playing a vital role in the form of machine learning, along with artificial intelligence, along with image processing applications. So why do we want to focus on medical imaging? To diagnose, treat, and cure patients without causing any harmful side effects. So highly useful medical imaging applications. So for that purpose, computer vision also can exploit texture, shape, contour, and prior knowledge along with contextual information from image sequence and provide 3D and 4D information that helps with better human understanding. When the treatment is going on side by side, some modality will be there, and they will physicians and the experts will see that, and based on that, surgery will take place. And also to identify the scenario and how it is stage 1, stage 2, stage 3 cancers and other things. This type of modality will be highly helpful, and in order to save the patients, this is highly useful, a very important application which has to be focused. So a lot of research is going on. We have done a lot of research based on this work. So brain tumor reduction based on Brad's 2018, 19, 20 models, and now we are just moving on to AI with XAI. That is, XAI is nothing but extendable AI, which will give interactive applications. Then we are now going with GAN applications to see inside a patient without having to cut them open. So the internal organs of the body could be analyzed based on the different imaging modalities through CT scan or MRI scan. So through which our doctors can identify and they can do surgery and treatment and diagnosis. Everything could be done very accurately without any harmful side effects. This is the very important and useful feature. Based on this, image processing contributions could be done a lot to the society. The final objective is to benefit the patients without adding to the already high medical cost. So based on the modality scans and other things, this could be done comfortably with the different modalities with imaging applications. So what is all about computer vision system? Here we have an image processing technique. Then, as I have already mentioned, one of the keyword called as segmentation. Based on threshold, the region of interest, which portion is affected, that could be analyzed based on this segmentation process. Then feature estimation is nothing but what type of feature which is present in this given image in the form of geometrical, topological texture could be analyzed. Then data analysis could be done with recognition, classification, and interpretation, along with whether it's a healthy tissue or not. That could be analyzed with the help of data analysis after verifying the features extracted from the segmented portion of the given image. Then followed by, we need to apply our hardware and software with knowledge base through which we can come out with our algorithms and we can analyze with our contributions. Based on that, we can say whether it's a healthy tissue or not. So through the modality, based on the input image processing could begin, and segmentation, feature extraction, data analysis, computer hardware and software. Based on that, we can apply some algorithm and we can contribute towards the decision whether it's a healthy tissue or not based on the computer vision system. This is being deposited in this particular slide in the medical image processing applications. So when you talk about medical imaging, in day-to-day life, we have X-ray, computer tomography, MRI, nuclear PET, then PET, then followed by ultrasound images. So depends on the nature of the disease. A doctor will advise for certain type of modality through which imaging patients' diseases could be analyzed, and doctors can give detection and diagnosis and followed by treatment. That could be that could be initiated. So this is an X-ray image. This is another magnetic spin image of the brain tumor. Then followed by metabolic tracer X-ray emission, which is shown here. Then based on that, we have in cancer vitro and in vitro images based on computer-based images. Lot of treatments are going on at present. Then this is another example for ultrasound. Based on that, pregnant lady could analyze about the fetus, and based on that, they would come out with the healthy baby in different days, months. So single photon emission computed tomography, position emission tomography, ultrasound, nuclear magnetic resonance. We are taking some samples based on X-rays, CTs, and MRI, and based on the datasets, we are applying some novelty. We are providing some contributions as novelty of the given image by understanding the existing drawbacks, and that could be improved, and we improved the accuracy of brain images. And now at present we are working with cancer imaging. So this type of research work is going on, and we are published in SciIndex journals. So we have the experience of working under these imaging applications. So with this architecture modules, I can say that we have acquisition and digitization. Digitization is nothing but sampling and quantization of the given image. This is called as formation. Then followed by we have calibration, registration, optimization, transformation, and filtering. This is all coming under enhancement based on low level processing, low filters or high filters. We have low pass and high pass. We can do certain outlay detection and other things with this as a pre-processing step. Then we can go with another 3 categories after enhancement, maybe visualization, or we can go with analysis. Along with, we can go with management. So let us see what is visualization: surface reconstruction, illumination, shading, display. Sometimes it is not possible to know the tissue as such. We can give false coloring, through which we may be able to identify what type of problem in this cell could be analyzed. Then feature extraction based on textures, colors, shapes, then geometrical shapes, then size of the tumor, other things could be extracted. Then region of interest should be extracted with the help of the thresholding technique. Then classification. We need to identify what type of classification is done based on the segmentation, whether it's a benign cell or it's a non-benign cell. So healthy cell or not. Then interpretation based on the given algorithm, we may be able to identify, and we can use some performance measure through which we may be able to find the accuracy of the transformation. Then filtering is enhancement process, after which we have to store it in the database. So it is essential to have some compression. Then it has to be stored in the backup. Then it has to be retrieved later. Then communication for the patient, and insurance people also will maintain that as a management. So this is the architecture modules with respect to medical imaging. I hope this is clear to everyone. I may continue.
Yes, ma'am.
Yeah. So these are all different modalities, as we have seen, right? When we have ultrasound images, this type of vibes will be given. Then everywhere in MRI scan, CT scan, in PET scan, these are the different modalities through which we will be getting images that could be taken forward to analyze further, right? So with this, what are the different types of image processing techniques are required, and how medical image processing is analyzed, that have been given as an introduction. I think with this, medical image pre-processing also involves the same procedures like enhancement, filtering. Filtering means noise suppression, contrast enhancement. So that could be done, right? Noise suppression is nothing but removing noise. Contrast enhancement, one such example we have seen is histogram equalization. So all these things can be done. Low pass filters, high pass filters, highlighting fine details, highlighting edges, all these things could come under this filtering. Registration, and then calibration is nothing but outlier elimination, bias compensation, time space filtering, all these things are coming under this. Then transformation, if we have a prior knowledge, then raw data is given, pre-processing steps as an algorithm, then pre-processed, then cleaned, enhanced data will be given as a transformation. So we can work with directly with pixels, or we can directly work with some frequency domain functions. Then based on that, we have two cases. One is spatial domain application, another one is frequency domain applications. The objective of filtering is to remove noise. So noise is very important, important element to be eliminated. Disturbance. While taking in a snapshot of the given image, we shake, right? While shaking itself, we are getting this problem. Averaging filter, median filter, maximum minimum filter. These are all smoothing. That is, these are all called as low pass filters. Let us see what is a filter. Filter is nothing but one small 3x3 or 5x5 or 7x7 window that could be moved throughout the image. In order to find the mean filter for a 3x3 pixel, 1x9, 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 1x9. So 3 rows, 3 columns, every element is 1x9. That has to be moved around, through which it is called as a supervisor also. Based on the convolution function or correlation function, it could be applied and we can make it smooth. This is called as averaging filter function. Median means you have 9 elements, through which central element you take it and replace that with the output. So that also gives some better performance of smoothing, right? Low pass filter applied. Maximum, out of the 3 rows, 3 columns, find the maximum, then substitute with maximum instead of the already existing original pixel. So minimum, out of 9 for the 3x3 filter, you apply this and you will get it. That is nothing but our filtering. So you have to go with convolution. Convolution is nothing but sum of products. So in order to find we with the limited time, I could see filter. I have just given you as a explanation. I think this is a small window that is called as a kernel, which is involved with the convolution function that moves around from 0, 0 pixel to m-1, n-1 pixel. Such a way we will be achieving the smoothing function. The aim of image smoothing is to diminish the effects of camera noise, spurious pixel values, missing pixel values, etc. Two methods used for image smoothing are neighborhood averaging, edge preserving smoothing. These are all examples shown to remove the noise, right? Through which we may be able to smooth the function. Blurring effect will be there. Registration, medical image registration for data on same patient taken at different points in time, such as change reduction of tumor monitoring. So this is unimodal registration example. This term refers to the relative calibration of images with different angles, right? That have been required with the same modality, and this unimodal with one modality. If you go with more than one modality, the images to be compared are captured with different modalities, through which we may be able to achieve registration. For patients' clear diagnosis, registration will be helpful with different orientations. So the next one is transformation. Image transforms can be simple arithmetic operations on images. As I have already told you, averaging. What do you mean by averaging? When you have a 3 rows, 3 columns, add all the elements of 0, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 2, then 2, 0, 2, 1, 2, 2. So all the 3 elements that has to be added and divided by 9. That is a simple operation for 3x3. Similarly, we can extend with 5x5 neighborhood operation, 7x7, 9x9, depends on the requirement. So this can be simple mathematical functions, arithmetic operations. So normally we will be using, if it is a minimum, if it is a averaging, we'll do addition and division. Similarly, we have to do convolution method, means we need to perform sum of products. All these things could be done throughout the image from 0, 0 to m-1, n-1. All the pixels will have to be processed. The transformation is intended to select the most prominent or relevant features. For that, we can also apply discrete Fourier transformation, discrete cosine transformation, discrete wavelet transformation. When you take discrete Fourier transformation, when you have input image, when you have some set of images and somebody wants to recognize the image, you take the person's biometric. One of the biometric is image recognition, face recognition. You take the face of the one input image and apply discrete Fourier transformation, and whatever the sample is coming inside, right? Person is coming inside the particular office. That particular image has to be compared with already existing stored DFT of the images. If the correlation is greater than 0.9 to 1, so maximum value for correlation is 1.0, right? So therefore 0.9 to 1, we can say the same person has been recognized. So he is eligible to come inside. Such a way we can apply discrete Fourier transformation. Cosine transformation, for example, JPEG compression. The given input image is transformed with discrete cosine transformation. Then through some encoding procedure has been done, then decoding, then compression takes place and the size has been reduced. Discrete wavelet transformation, JPEG 2000 is applying discrete wavelet transformation. This is a multi-resolution processing have been applied, and through which we have LL, LH, HL, HS, filters are applied, and through the LL space detailed coefficients we can apply compression with encoding procedures. Then based on some quadri coding and other things, we can apply bit stream. We can reduce the size of the input image. Then we can come back to the decoding, and quality should not be compromised. In such a way, people work with that. So these are all certain applications in which we can go with Fourier transformation, cosine transformation, wavelet transformation. So sometimes people will directly work with pixels, that is spatial domain. If they apply this Fourier transformation, they will get some frequency analysis could be done easily. After completing this, it has to be transformed back as an inverse discrete Fourier transformation. So they will get the original domain. Similarly, discrete cosine transformation, after doing compression, again do the reverse DCT, inverse DCT, you will come back to the original domain. So this is exactly reproducible, reversible. So it is possible to easy from one domain, spatial domain, to then discrete wavelet transform, frequency domain. Then after doing some certain applications and processing, we can come back to the original position. So this is called as transformation. So why do I talk about all this? Everything is readily and required for our medical imaging. So it is necessary to know this processing to apply. So it includes all the steps of pre-processing like feature extraction, segmentation, classification. So we are going to see about models, deep learning models. Once if you want to work with deep learning models, our model has to extract features based on the region of interest, and it has to classify whether the cell is benign or non-benign, right? So that has to be healthy tissue or healthy cell or not healthy cell. That has to be identified. Benign or malignant. Benign means normal. Malignant means not normal. Therefore, it has to identify. So these are the 3 steps which has to be taken care by our deep learning models. For that purpose, this analysis part is given here. Feature extraction, segmentation, region of interest, classification based on classifiers, SVM. So this is one simple classifier. Then regression analysis. We have a lot of mathematical functions available through which we may be able to identify whether it's a healthy cell or non-healthy cell through the different networking model also existing in the literature, through which also we may be able to identify. So here we can also contribute. So images, volume sequences are being given as an input to the high-level processing, then with the prior knowledge as a database through which we can identify some quantitative and qualitative information based on that size changes and metabolic information. With this, we can come out with classification. These are all the analysis which has to be carried out with 2D as well as 3D images. If you apply X and Y axis alone, it is called as 2D. Easy to implement. When you have now CT, MRI images, DICOM images, and nowadays nifty images are coming out from the cancer part of it, diagnosis, then scanning time. So that image also could be directly worked. That is called as 3D. So it has to work with X, Y along with Z. It is nothing but depth or opacities that has to be taken care. So it is quite complex to work with 3D. But anyway, that 3D also could be converted into 2D as a dimensionality reduction, and each slices could be separately worked and we can merge. That way also we can do the analysis. So segmentation, as we have seen, pixel-based segmentation could come under 3 different types of thresholding: adaptive thresholding, clustering. Then edge-based segmentation, live-wire segmentation, snake algorithms are available, active contour algorithm is available. These are all some of the samples which is given here. Then region-based segmentation, agglometric algorithm, then division algorithms, then hybrid algorithms. So these are all different techniques which could be applied. If anybody wants to work under this, you can find out from me the detailed processes over here. We have separate algorithms for everything, and these are all existing algorithms. Along with, we can also provide our contribution. So feature extraction is defined as the first stage of intelligent high-level image analysis. It is followed by segmentation and classification. So levels of feature extraction in the data level, region level, texture level, edge level, pixel level. So this way we can go with our segmentation, then based on region level, texture level, or based on contour level. That way we can work and we can provide solution. Followed by feature extraction is important in medical image analysis. For any recognition, object recognition also, it is important to know what type of feature is present. As a knowledge base, it has to be provided, and based on that deep learning models, we can come out with the extraction, and it can be given as an input. Then based on the classification, a comparison to developed atlases, classified image, use of knowledge databases. Classify is normal. We have a lot of functions, activation functions and other things available. Then through softmax classifier, we may able to work out and we can classify whether it's a benign or malignant. So nodule is nothing but a portion of the cancer part. Affected part is called as lung nodules. That determine cancer or non-cancer. That could be identified as a one simple application in the medical imaging through classification. Image visualization is also playing a vital role while doing diagnosis and treatment by the physicians to the patients. In refers to all the manipulation of these matrices, resulting in an optimized output of the image. So this is a 2D and this is a 3D part. Can you find the difference? 2D. So here we have only X and Y part and with gray matter. Here we can see X and Y along with elevations of actual presence of the tissues and other things are being elevated as a 3D. Even we can go for multi-dimension with time and motion. That is video and other things, right? While scanning, doctor can see this. Our radiologist could see this. Then 5D. 5D means from this we can apply some new false coloring, and based on the false coloring technique, we have tools, and based on that we may able to, or we can apply some algorithm to make it like this. And fluid dynamics, how the fluid is present in the human internal organ of the body, blood flow, all these things could be analyzed. So these are all the image visualization. Image based on the image visualization through the modality like MRI or PET or SPECT, people can have this type of images. So now this is the lower level processing. Then this is 3D processing with one more opacity, right? Height that could be added. Then this could be converted into 4D also with time and motion. Even multi-dimension, it can be extended to 5D with fluid dynamics and blood flow for the patient treatment analysis by the physicians during the diagnosis and other treatment. So shading, display, reconstruction, all these things play a vital role in this part, 4D and 5D. So this is another image, right, which will also show the level of how the data shell density and the affected tumor is present. All these things could be, shading could be done. So we can do this type of processing with visual image visualization techniques. We have algorithms that has been implemented as a tool. Through the tool, our doctors can use it through with the help of the radiologist, they may be able to come out with the scan and image formats. Fusion, melting together images from different modalities to create a new image. So normally people will have to take one CT and one MRI and you can use it, and based on that multimodal fusion will give more information to the doctors, right, for the treatment. So for the benefit of the patients, technology is being advanced in the medical domain. This could be done with the shading and other things, and region of interest, fluid dynamics could be done with time and motion. So based on that, we can get. So this is NMR with spectrum. Instead of taking only one image as output from the modality, more than one or NMR spectrography and other things could be combined, CT plus PET. So something we can combine and we can get some accurate solution could be given for the patients. So these are the applications. I will go with some more slides. I will take a few minutes to complete this. Diagnosis, combining information from multiple imaging modalities is playing a vital role in the diagnosis. Accurate diagnosis. Studying disease progression helps the patient's life. Monitoring changes in size, shape, position, or image intensity over time, especially in stage 1, stage 2, stage 3 cancers, people could be monitored. Patients could be monitored by the physicians clearly. Then image guided surgery or radiotherapy helps a lot for the patients to save their life by the specialist, expert doctors, relating pre-operative images and surgical plans to the physical reality of the patient. So in all these places, 3D images are playing a vital role. So XY along with height, along with motion, time, along with shading. So this plays a vital role. That's why we have chosen deep learning model for 3D image processing applications as a AI part. So patient comparison or atlas construction, relating one individual's anatomy to a standardized atlas, all these things could be done. So these are all different companies, healthcare with AI, emerging and providing services, medical imaging diagnosis. You can see Zebra and other image. These are all the different places companies are working under this domain. So researchers are going on and they are updating their tools, TAG, Sigeria, then drug discovery. We have a lot of nano-based particles could be applied in the cancer therapy. All the things people are doing research and they are updating. Then wearables, this is computer vision. Through computer vision, we may be able to feel also. Illusion could be made. And the doctors can do the rehearsal of the surgery also with the help of wearables through virtual reality. Then emerging room and surgery. So different modalities are available. Inpatient care, hospital management, these people are working on it. And these are the companies, miscellaneous, they are all providing a lot of solutions for healthcare with AI. Then Rome, these are all the different people, they are providing services to AI. So as our professor has rightly pointed out, AI is not replacing the person. It is providing job opportunities for the intelligent computer scientist to work with. That is the main idea behind the healthcare with AI applications. So we can contribute more by automating things with the help of the knowledge base. So this is deep learning. Deep learning is nothing but digital knowledge base, patient demography, data, then clinical decision support, the artificial intelligence system with analysis. That is computer-aided diagnosis and treatment selection through machine learning algorithms, synthesis results for recommendations. All these things are coming under this healthcare with deep learning. As you know, input, feature extraction, classification, output. If you combine feature extraction and classification as a one network, automatically it provides a solution as a whether it's a malignant cell or benign cell. So simply here car, if you come out with the answer whether it's a car or not, it should is called as a deep learning model. So we are talking about deep learning models, simple neural network which consists of input layer, hidden layer, output layer. When the deep learning means more than one hidden layer. Feature extraction and classification has been combined with more than set of hidden layers. Is a subtype of representation. Deep learning is a subtype of representation learning which aims to describe complex data representation using simpler hierarchical structures defined from a set of specific features. So this is nothing but CNN, convolutional neural network, to better understand this definition. This is a difference, right? Neural network, as you know, input, one hidden layer, one output. If you combine more than one hidden layer with the processing for feature extraction and classification, automatically it is called as a deep learning. Normally people will term that as CNN, convolutional neural network. This is an overflow. So we have an input image, then we have pre-processing and reconstruction, then we have quality enhancement, image enhancement, then region of interest, segmentation, then followed by detection, lesson detection, then followed by through imaging and clinical and technical only, it is all possible with algorithms. Then we have lesson segmentation and classification based on whether it's a healthy or non-healthy cell. Then all these things could be done, monitoring based on the progress of the patient's cells day to day. The doctor has to watch and they have to provide, then they have to predict and how the diagnosis and how the treatment has to be gone. So this is clinical uses of deep learning techniques, very important to save the mankind when there is a patient. A convolution neural network is a type of neural network that specializes in image recognition and computer vision task. So input, then we have feature maps. With the help of the filter only, we may be able to come out with convolution, then followed by pooling layer, then max pooling, we can reduce the size, then pool feature maps, that is segmented portions could be identified. Then after which, after segmentation, we have to go with vectorized feature map as a single dimensional array, then through which we have to find whether each is an output. So softmax function is used. So we have multi-class functions, so binary functions. We have different functions available in each layer that could be seen, and we have a lot of architectures readily available in the literature. Just I'm introducing the name of that, and you can also learn and you can contribute your architecture based on these basics. Each one is having its own, sometimes accuracy is not clear. So we can improve the accuracy by means of introducing our own architecture. This is the input image for recognizing whether it's a car or not. Then convolution, we are applying the filter, and through that object could be extracted with the help of the pooling. Then convolution, through which again pool it. Then you just fully connect a layer with the help of the softmax function. We may be able to come out whether it's a proper 1 or 0, 1 match, 0 doesn't match, something like that. We can come out with feature map. Then you can say whether it's a given object is recognized or not. This is small slide. Architectures, this is very important in medical image analysis. Please make a note of it. AlexNet, VGG, GoogleNet, ResNet, Highway Nets, DenseNet, GANs. So all these things are readily available in our literature. So ResNet, CNet, NASNet, YOLO, SIAMS Nets, UNet, VNet. So now let me introduce only ResNet and UNet. If you are really interested, please go through and Google it and understand what every net is doing. These are all nothing but convolution neural network architectures. Each one is having its own features. YOLO is mainly used for object recognition, right? YOLO versions are available, 2.0, 3.0, 4.0, 5.0 for object recognition. So when you talk about the self, that is driverless cars, people are working with YOLO architectures, object recognition. All these things, YOLO plays a vital role. In medical imaging, we can use with UNet and ResNet also. We'll see what is what. And next, I think 3 to 4 slides, I'll finish it off. Shall I proceed?
Yes, ma'am. Definitely.
Okay, thank you. Convolution neural networks are successful for simpler image tasks such as classification. As we see, whether it's what type of things available. So to identify and to improve enhancement, we apply the convolution with different filters. Then features will be extracted, after which everything is fully connected layer through which it will identify whether it's a healthy cell or non-healthy cell. More complex ones like localization and segmentation could also be, finally, we can arrive with that. This is a localization and segmentation for the region of interest. Then coloring could be added. So finally, we can find the difference also. So these are all some examples which is shown in this slide. Biomedical cases. In biomedical cases, it requires us not only to distinguish whether there is a disease, but also to localize the area of abnormality. So in this case, doctor has to know which part of the cell portion of that organ is being affected, through which we may able to do segmentation problem. Through the different tools, we may able to come out with our algorithm to identify as a bounding box as based on thresholding. I have listed a lot of methods, right? Adaptive thresholding, pixel-based segmentation, then everything could be applied, through which we may able to come out with these windows and to identify the localize the area of abnormality. After segmentation, it is essential to know which portion of the organ is being affected through the window. That is segmentation. Localize the area of abnormality could be identified in the biomedical. So for example, to identify the localized area of abnormality, how much portion, what is the area of the size which is getting affected, that could be analyzed with the help of UNet and ResNet. So I think I have taken this as a highlight, UNet and ResNet, to identify the localized area of abnormality in the future slides. This is a UNet architecture. First, realize a suggestion for better segmentation on biomedical images. In CNN, the image is converted into vector, which is largely used in classification problem. But in UNet, an image is converted into a vector first, and then same mapping is used to convert it again to an image. Simply say, it converts a segmentation problem into a classification problem, where we need to exactly classify each pixel to one of the classes, whether it's a malignant or non-malignant, something like that. We may be able to do that as a map. This is the UNet architecture input. Then we have some filtering apply, then hidden layers. Then this is encoding layer, after which pulling. Then we have to reverse as decoding, and we have to come out with the output segmentation map. So UNet we are applying to our cancer imaging analysis for liver and bone cancer at present in our research work. ResNet is residual networks addresses that vanishing gradient problem. Vanishing gradient is nothing but towards the solution, right? It should not deviate. It should not give any false identification. That is make sure with the help of ResNet. In traditional neural networks, each layer feeds into the next layer. But in a network with residual blocks, each layer feeds into the next layer and directly into the layers about some hops away. So not only with the next layer alone. After this is a hop, right? This is hop. Each one is called as a hop. So after this hop also, we may be able to identify what it be. That is a main idea behind the ResNet. So these are all the different architectures which is readily available. If you are able to understand, if you want to understand, please go through the literature. Everything is readily available, and we can also modify the literature as new techniques with respect to our pooling layers and different functions. Activation functions could be changed, and we can come out with performance, improved performance. After performing all these deep learning models, it is essential to find out this thing, right? So what is that? Observed information and true information. So object is present, and in the observed information also object is observed. This is called as true positive. Match is present, right? Object is not present, but object is observed. It is called as false positive. So every time we have to analyze this performance analysis for input as well as versus output, observed information in the automatic detection in the CNN. So object is not observed, but object is present. In the case of true condition, it is called as false negative. So object is not present in the true case, but in the observed information, true, it is not observed, it is called as true negative. So based on this, we have the formula and the precision recall and other things. Based on that, we can find the accuracy of the proposed system. So this is what people will do it. In nowadays, we have all data available in the dataset library. We have BRADS for brain tumor datasets, standard benchmark datasets available. Similarly, in net itself, everything is available, TCIA datasets everywhere. So people are using some challenges, and based on that, they are also coming out with labeling tools. So through the labeling only, we'll be able to take that images and we can process and we can give some solutions. If label is not present, As an image analyst, we can also prepare labeling cancer images, and based on the nature of the knowledge, we may be able to come out with labeling, and based on segmentation and other portions, feature extraction, we can come out with classification and store the data. And this can be stored in the XML or Excel in the form of clinical data or in the form of image data, and we can work together. So we have label imaging tool, readily available tools are also freely open source tools available, through which also we can try. This is one of the labeling tool through which we may be able to identify the portion where the data is that portion could be segmented, and based on that we may be able to segment, and we can give this as an input to our model, and we can come out with outputs. Image tool, labeling image tool. This is available, and you can work with this. This is one of the tools we have come across to store it in our Excel file, and we have started. So these are all real-time examples. Notable breakthroughs: Google Health, DeepMind, Google's AI breast cancer screening tool is learning to generalize across notice. Not only creating awareness, we can also come out with some tools which is readily available. Based on the tool, people can understand the normality and diagnose things clearly. These are all useful societal applications which is required to save the patients, right? To save the patients quickly. So with the help of artificial intelligence, deep learning models, based on the image analysis techniques through segmentation, then in first pre-processing, enhancement, segmentation with different mathematical formulas we have seen. Then importance of 2D images, 3D images, motion images, time domain images, along with the shading. Then we have been come out with deep learning models. What is a CNN? And first we have seen what is a neural network. Then CNN. Under CNN, we have a lot of models available, many models available. We could see ResNet and UNet and how it works for localizing the cells of the patients. Not only with segmentation, whether it's malignant or non-malignant, we can also identify what type of disease is present and how much it is affected, in which area of the particular organ is affected, could be done through different AI applications, deep learning models. So with this, I have come to the conclusion. And if you have any clarifications, I'm open now. Thank you for your patient listening. Once again, thank the organizers for having provided me the opportunity to interact with the dynamic group like you. Thank you.
Thank you so much, ma'am. As you have explained very well on key stages of processing and image enhancement, also put a light on block diagram of cancer image using image processing technique. You have also explained methods on 2D and 3D image. Thank you so much, ma'am. If anyone wishes to ask anything regarding the topic, kindly unmute yourself and ask questions. Anybody? If you are interested to ask anything, please kindly unmute yourself and ask question. Okay, there is no responses. I don't think there is any query from the participant side, because as you have explained very well, ma'am. Thank you so much, ma'am. It was such a lovely session. I sincerely appreciate you for a session that was both enlightening and incredibly instructive. I'm sure we can all learn so much from your speak, as you have explained very well on deep learning models for 3D medical image processing. I'm sure that it will be very beneficial for all the scholars, researchers, and delegates. Thank you so much, ma'am. I really appreciate your time. After this wonderful session, the first session will be conducted by Ms. Purva Wad, ma'am. Let's take a break of 5 minutes. Till then, enjoy video. Thank you so much, everyone. I, Shivani Misawat, take your leave and have a nice day. Once again, thank you so much, Dr. Chitra ma'am, to share your opinion and views.
Thank you very much.
Thank you so much, ma'am. Good afternoon, ladies and gentlemen, distinguished guest, esteemed speaker, and all participants. Welcome to the first session of Day 1 of 2-day Interdisciplinary National Conference. I, Ms. Purva Wagh, and it is my pleasure to be your anchor for this event. We are gathered here today to delve into technological advancement in computer science, artificial intelligence, machine learning, and data science, organized by Department of Computer Science and Application of our college, Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts. We are honored to have our honorable resource person, Dr. M. Prasad, and moderator, Dr. S. Rajkumar. Also, we have diverse group of attendees, including professionals, experts, and enthusiasts from various fields. Welcome you all. Your presence here is a testament to your commitment to knowledge sharing and learning. Our first session will focus on visualizing the future trend and innovation in data visualization. Our speaker for this session is Dr. M. Prasad. Speaking about our resource person, Dr. M. Prasad, he is working as an associate professor, computer science and engineering department at Sri Vishnu Engineering College for Women, West Godavari District, Andhra Pradesh, India. He completed his bachelor's, master's, and doctorate degree in computer science and engineering. He has more than 18 years of teaching experience. He has 2 years of international teaching experience in Ethiopia. He has guided more than 25 projects at UG, PG, and PhD level. He had organized more than 20 seminars, workshops, and symposiums. He has presented more than 35 research papers in reputed international, national conference journals. Apart from being a professional member of more than 6 professional bodies, he also served as a resource person, academic, subject expert, organizing member, reviewer, examiner at numerous renowned conferences, student workshops, and faculty development trainings. He brings a wealth of experience in machine learning, data mining, cloud computing, mobile application development, network and system security, visual data analytics, IoT, and ethical hacking. Now, I would like to introduce our moderator, Dr. S.
So understanding of data will be done by the so many systems or technologies, but once they are processing the data processing information is to show to the end user. Maybe that is machine learning or data science or any AI or IoT technology. Finally, it gives the processed data. The processed data must and should be shown to the end user. If you are unable to show to the end user in meaningful way, it's waste of entire process. So that's why we are go with the data visualization. So data visualization is a science to analytics, the reasoning facilitated by the interactive visual interfaces. For doing of data visualization, there are two components are required. One is tools and second one is the processes. If these two components are available, then we can definitely creating the good visualizations that will be better understood by the end user. So once we are analyze the data set using of sophisticated data tools and processes, how we are representing the data to the end user? Humans are very interested to see the images. They are unable to recognize the data in a text format. It's a less cognitive power. That's why our data, visualizing data in terms of the graphs, charts, maps, like that. So finally, what it helps? It helps to take the better decision. That decision is also a data-driven decision. Okay, sir, we are talking about the data visualization. So where it is come? The data visualization is part of the data science, and the theme of this conference is also the data science.
Sorry,
So
sir.
that's why I'm
Sorry
taking.
for interruption. Your slides is not moving.
It's not moving, ma'am.
Yeah, sir.
Yeah, 1 minute. I will reshare it.
Okay, sir.
Now, okay, na, ma'am? Hello.
Yes, yes, yes.
Is it moving now?
Yes, sir, it is.
Yeah, thank you. So data visualization is a subset of data science. Subset of data science. Okay, why we are going to the data visualization? Why we are going with the data visualization? So data visualization makes the better communication with the end user. It is also visible communication, not the text communication area, any other communication. If it is a visual communication, it will be understood by the end user very perfectly, and what type of data you want to see in the particular fashion for taking the decision, the data visualization gives the perfect one. And it supports the human perception and cognition. And data overload issues. If suppose one student have 8 semesters, in each and every semester they have the 6 subjects. For each and every subject, internal marks, assignment marks, and external marks. So if you are providing that data to the interviewer for understanding of the academic performance of the student, it's definitely within 1 minute or 2 minutes the interview will not understand. Then what the student will do? The heavy load information will be converted into the diagrammatic representation like graph. In first semester, how much percentage he got? In second semester, how much percentage he got? If it is incremented way, then the interviewer can assume the student is continuous learner, and he can identify his problems, and that will be rectified in the next semesters. So then within 1 second of time, using of that visual representation in terms of the bar graph or any other graph of the student marks to the interviewer, definitely he will impress. So data overload problem will be overcome using of the data visualization, and it gives a better clarity. And it is totally data driven decisions. So what are the different types of data visualization? Nowadays we are talking about the data visualization, but it is not correct. In 10th century itself, the data visualization is there, but at that time they are using a pen and paper or pencil and paper, they are draw it. And for drawing that one, they have to do lot of analyzation. So here we are seeing some graphs in that will be drawn in the 10th century, and this is the one site map, how the people are scattered in the particular site they are drawn. That is old generation. Now in modern generation, the data visualization will be provided to the end user using of different graphs, charts, and maps. Totally, I think 35 plus data visualization charts or maps are available. Depends upon the tool. What depends upon the tool we are using. When you are go to the Tableau, it supports 30. When you are go to the IBM Cognos, it is around 28. I think so. So like that, when we are change the tool to tool, then the supporting data visualization types are also changed. So in this presentation, just I want to talk about the process for generating the data visualization and what are the different principles which are followed in the data visualization. So I didn't talk about what are the tools available and how it will be work, because most of the tools which are available in the market for data visualization, it is completely fully GUI. So there is no need to understand much for that one. That's why I am concentrated on what is the process to generate the data visualization. Okay, we have the number of data visualization types are there, like different charts, graphs, and maps are there. So out of that one, for my data, what type of data visualization I will choose? That is the biggest question, because bar graph is there, heat map is there, tree map is there, so many are there, bubble chart is there, so many types are there. In morning session, Dr. Ravinder Singh, from professor from Punjab University, he explained the AI using of bubble chart, how AIs impact the society and what is the AI market in the computer science. He explained in the bubble chart. Suppose if he present that data in the tabular form, we are unable to understand. Clear? So what type of data I have and what purpose I want to make the visualization depends upon this one. I have to choose a right data visualization.
Sir,
Sir, you are not audible.
Prasad sir. Sir, you are not audible. Participants, kindly stay with us. There is technical issue from the resource person side.
Hello, Poro madam, is okay now?
Sir, yes, sir.
I didn't get any response from your side, that's why.
Oh.
Okay, no issue. I will go. So screen is visible now,
Yes,
correct,
sir.
ma'am?
Yes, sir.
So suppose I want to make the comparison operation in between of two entities. Generally, we have the two types of data which is available in the data set, that is quantitative data and qualitative data. So qualitative data is also sometimes it is a categorical data. Suppose I want to make a comparison operation. Suppose I want to make the comparison operation in between of quantity and quantity, then scatter plots are the best one. And suppose we want to make a category versus quantity, then we have to decide how many number of categories we are considered in the comparison. So if it is one category versus one quantity, then bar chart type, tape diagram, pictorial diagram, line chart is good. If it is two categories are there, some more slides, bar graphs are there. Suppose I am using the three categories like gender, country and income tax, like that, and I want to compare that one with the IQ of the student, then it is multiple graphs like pivot tables. So like that, I want to give the some more explanation about the right DV choosing. Suppose I want to make the comparison of in between of strengths and weaknesses. Strengths and weaknesses. Strengths and weaknesses.
Yes,
Then our radar chart is there. Suppose I want to make the business goals, bullet graphs are better. Showing geographical data, then geographical data and dot maps and connection chart, correlate maps are better. Okay. These are the various data types, data visualization types are available in the different tools of the data visualization. Now, how to generate the data visualization? So that's pipeline, the process of data visualization. Here we are taking the information from the raw data. We want to perform the operations on raw data and we will get the visualization. But raw data is very complex one. The raw data generally it is information that should be converted into the data tables. So once the data tables are generated, in between of that one we are doing so many things. I will explain one by one. And after data tables I am getting, then that data tables are converted into the different virtual structures.
Yes.
And the virtual structures will be transformed into the visualization. This is the views. Using of these views, the end user will explore the data and discover the data and validate the data as per his need. When we are seeing the data collection, the raw data should be collected. From where we are collecting the data? So collecting the data from the various sources and like databases, spreadsheets, API, sensors, and relevant data is from analysis. So once that data is collected and it is to be raw data, it should be cleaned before converted into the meaningful tables. It should be cleaned. So for this cleaning process is called as a pre-processing phase. This pre-processing phase where generally raw data contains the errors, sometimes missing values, sometimes inconsistency data is there. All these to be cleaned fast, and the quality and sustainability of visualization to be improved. How much clean we are done, then it decides the sustainability of the visualization. So in this one, we are performing the different operations in the pre-processing, data imputation, outlier removal, and standardization procedure. Once it will be done, the cleaned data should be transformed. So depending on the goals of the visualization. As per goals, we are transformed, because all the tables and in that tables all the fields will not be useful.
Yes, sir.
So will not be visible. Some columns of data or rows of data is not meant for visualization. It is not used for current visualization purpose. So that's why. So we can perform some transformation operations like a selection, projection, aggregation, and join, transfer, sort, like this of operations will be performed on the data tables, and we will get the meaningful data which is suitable to our data visualization. And next we are go with the data explorations, means visual structures we will to be converted. So creating final virtualization, it is very essential to the data. In this step, generating the summary of statics, frequency of distribution, and conducting exploratory data analytics EDA on the data characteristics and identify the patterns. Once all these to be done, then we are go with the visualization. So in visualization, we have the different varieties of data visualization tools, like different varieties of graphs, charts, maps are there. Which one is the best one? Already we are discussed that one. So like this one, we can perform the data visualization process for raw data collection to the generation of the data visualization. Okay. Is very good. The process is very nice from collecting of data to the generating of visualization. So what are the principles you have to keep in mind for making of effective data visualization? So everyone has its own perception, but it is not correct. That's why one person is a very good person, expert in the data visualization, Edward Tufte. So in my opinion, he is the father of the data visualization. So in 1960s itself, he told how the data visualization will be there. He makes some standards as per his. there are three principles to generate the effective data visualization. One is the chart should tell a story. Chart should tell a story.
Yes, sir.
And chart should have graphical integrity. The chart should be minimize the graphical complexity. Graphical complexity. So first principle we will take, the chart should be tell a story. The chart means data visualization. So in that one, the graphic should be clear on their own. You can use less graphics to generating the data visualization. And always we are talking about the meaningful comparison. Meaningful comparison. If you are taking the gender of the person and marks, sometimes it is useful. Suppose gender and college is in some situation it is not meaningful. So we can take the meaningful comparisons in between of two entities to generate the chart. So it's always should be beyond the test. If we are providing the test, it takes a lot of time. If we are providing the chart, why we are providing the chart or data visualization? Better understanding within time limit. If we are providing the chart in very complex manner, it's not useful. So that statics are boring. You definitely get wrong numbers.
Yes.
Second principle is the chart should have graphical integrity. So always the chart tells the truth. So, sir, how to calculate the truth? How much I am telling the truth in the data visualization to the end user? For that purpose, the person provides one life factor. Using of this one, you can assess the chart, how much it is accurately on the quantitative information. So the formula is very simple. Change in the chart divided by actual data change. The life factor as per the test should be 1, is nearer to 1. If it is greater than 1 means it is exaggerated information. That information is not understandable by the user, ineffective. If it is less than 1 means we are not providing the sufficient data through that data visualization to the user. So it should not be greater than 1 and should not be greater than less than 1. It should be nearer to 1. So for understanding this one, you can see the right hand side diagram. When we are observe this bar graph, here the number of victories we are considering, the percentage of victories. Here one person got 531 and another person got 424. So just you can see these two bars. The second one have the very lowest.
Yes.
But it is not correct. Because here the scaling is start with 400 and it is incremented 50 by 50 like that. When we are seeing the second one, we are start with scaling with 0 and 531 is the first one and the values will not change. But what is your impression on these left and right things bars? Here we are providing the false data to the user.
That's right.
So because the graphs, while we are seeing the graph, the user can understand something. When we are seeing the first graph, first one, the user feels the second person didn't get victory.
Yes.
Because is have sufficient one.
Yes.
So this type of mistakes will be happened. So that's why we should present the data visualization. Before that one, we should calculate the life factor.
Yes.
And principle 3 is there. Third principle, the data visualization must be minimized. That should minimize the graphical complexity. For this minimizing the graphical complexity, the Edward proposed the 3 principles. One is use simple charts, limit the number of data points and reduce the chart elements. It's very interesting. Coming to the next slide. So when we are consider the simple chart types, first principle under the third principle, first recommendation. So we are choosing the chart type as per your data. So don't go for the complex chart types. If your data is very simple, you can go with the simple charts. Sometimes the table is better than chart. Here you can see, here the salesperson is there, total sales are there. So if the total sales will be in sorted order, then you can easy to understand the peacock how the much sales. So when we are seeing this one, left side graph is there. If we are put the some concentration on this one, then we can identify. Generally we are generated the graph using of tables only. But sometimes for simple tables can give the better understanding to the user. So I am not recommending you go with the tables. Depends upon your data, you can choose. That's my recommendation. And second one is number of data points. Reduce the number of data points in the thing. So if the chart have overcrowding, we are giving the so many things in the single chart, it is not good. That's why the father of data visualization proposed another measurement, that is data ink ratio. The Tufty proposed the data ink ratio. So using of the data ink ratio, how much of data we are presenting on the one chart, that will be calculated. So data ink ratio formula is very simple. Data ink is divided by the total ink used in the graph. Ink in our language, the ink is number of pixels. How many number of pixels we are using, that is the how much of data we are presenting on the data. That's the relation, a small relation. So this one is also should be, the data ink ratio should be similar to 1, nearer to 1. If it is less than 1,
no data is related.
The data have the graph have the more non-data related information. If it is equal to 1, all ink devoted to the data. So you can understand using of this simple graph. I have the one graph of city crime. I don't know which city this crime rate. Here, when we are seeing this one, under the this line, they are fill everything. They are using the heavy number of inks, heavy number of pixels. So then it have the lower data ink ratio. It's the worst because the user can't understand why they are filled. And when we are go to the better one, here they are removing each and every x-axis lines, and they are removing everything, and they are point out the every corner information. Then it gives the more information that. So like that, data ink ratio will help us to generate the better visualization. And third recommendation of the Tufty, that is reduce the chart elements. In one chart, reduce the number of elements. So how I can tell these elements are sufficient? So one chart have the more number of elements, that chart is called as chart junk. If chart junk is there, it creates the clutter visualization and less effective and harder to interpret. So generally the visual clutter does not provide any additional sight. We are providing the so much of information in a single one. It didn't provide any additional insight. Suppose we are providing the per semester marks, in that one we are providing the every subject marks in a single bar graph. It's not useful to the end user. Right. Correct? Yes. I'm taking the student example. 8 semesters, every semester I have the different subjects. Yes. So for every subject, a different split is there: internal marks, assignment marks, and end exam marks. So we are providing every information. Generally, the comparison in between of what we are providing the everything. We are providing the everything. So it's not useful. It didn't give the any additional insight. Suppose in first semester, the max subject marks is not comparable with the second semester Python. So it's not useful, correct? So that's why. But one relationship is there. If the data ink ratio is low, the chart junk is to be high. So most of the times in various websites in internet, we are observing the different types of charts visualization. So sometimes they are using the 3D, but as per Tufty, it's not recommended. So you can understand how the chart elements will be reduced using of junk chart to the normal chart. Here, so much of information is there that will be reduced. Depends upon our requirement, we will follow the principles of TEFT. So these are the various principles to design the data visualization charts. So once, okay, this is for recommendations.
Right.
Sir, generating the graphs and is only thing is happened in the data visualization? No, so many from 2022 onwards, so many. I think 20 onwards, the data visualization trend is completely changed. These are the 5 latest trends I am considered in this presentation. Video visualization. Up to we are taking static visualization, data democratization, real-time visualization, mobile and social data visualization, AI and machine learning. It is our conference theme also.
Right.
So how artificial intelligence and machine learning is useful in the data visualization. So let's see one by one. So video visualization. So up to now, I think we are doing the data visualization things in their research work. Generally, they are preparing the dashboards. The dashboards are available in all types of data visualization tools like Tableau, Power BI, IBM Watson or IBM Cognos. So everyone is there. Dashboard, again, it have the static information. We have the multiple graphs. All the graphs are put in a single window, that is a dashboard, and these graphs will be rotated or placed in the order that is called as a story. But it is not attractive to the end user. Nowadays the students are very advanced. They are like the things in very good manner they are follow. That's why visualization will be happen in the video. The total visualization will be presented in the video format. Then it is a video visualization. So in video visualization, it have the animations, storytelling techniques we are following, and broad audience will be attracted. So it will be useful in journalism, education, marketing, and data analytics. So when we are seeing this one video visualization, I want to present a small video. Fast I will see. Availability.
Excuse me, Sanaka Srinivas sir, kindly mute your mic.
And observe here, everything will be represented in the graphs, but all are in animated way and created as a video, then easy to understand. Here, so many graphs they are used in the process. This is a bar graph they are used, but in animated way they are presenting. So how much of waste in daily basis they are shown in the liters and dishwashing like that. So like that we are presenting the data. This is called as data visualization.
Right.
So video visualization. Come to the second one, data democratization. So many people are thinking visualization will be happened using a coding programming languages. So coding is required. So not required nowadays, because we have a rich set of data visualization tools are available from Google to the small companies. They are providing the data visualization tools to the user. It is a fully GUI. Just open, drag and drop, and you can execute everything. So that's why the data visualization plays a crucial role, and it is an important concept in the data science field. So many are there. So even if you want to make the data visualization using of the programming language, there is a Python and there is a R programming also we have. Yes. So up to some level, Oracle is also supported. Come to the real-time visualization. So up to now we are talking about the student data. Student data is very static. Once the results are announced, the table is fixed. But in all the applications is not to be like that. Suppose when we are consider the weather information, every second a lot of information is coming. The lot of information will be real-time information will be processed in real time and presenting the visualization to the user. So when we are seeing the TV channels before the cyclone, they are well present the situation of this cyclone in the different areas. So how they are presenting? They are using the real-time data. So the static data maintenance is maintenance or visualization making is very easy. But when we are considered the real-time visualization, it is very hard. So for that one, so I am using the small video for better understanding of real-time data visualization.
Yes.
It's not working.
It is not working.
It's not working. I will. So I will go with the next slide.
Yes, sir, definitely.
I think it is stopped. So that is a real-time visualization I will show
Yes.
definitely. And next one is the data visualization. In previous days, when we have the laptop or a desktop, we will make it. Nowadays, the data visualization in the user hand. Data visualization in the user hand, because every person have the mobile. He like to see the visualization in the mobile. So it's compatible. The data visualization is compatible to the mobile versions, and social data visualizations also there. So when we are seeing the social data visualization, I want to show the one example.
Yes, sir.
Here I am opening my LinkedIn account. This is a social media platform. I am a very small person, and that's why I didn't have the much analytics in my LinkedIn. Here, so I have 1,163 impressions in the from last 7 days. So it is every second it will be changed.
Yes.
Depends upon the number of likes, impressions, and viewing. These analytics will be changed time to time. It's the example for real-time data analytics also.
Right.
At the same time, social media analytics also. And I have the LinkedIn app. I am able to these all analytics I am seeing in my mobile. So that is a mobile and social media visualization.
Yes.
And second one is AI and machine learning data visualization. So the data visualization will be happened. Okay, previously we have the artificial intelligence or machine learning for identification or processing the data. But the same thing will be used for presenting the visualization. So it improves the data decision making, user engagement, and business insight.
Prasad, sir, you are not audible.
Okay, madam, 1 minute.
Okay.
So finally, what we are understanding for making effective data visualization, there are requirement of some principles. So simple data visualization is better. Clarity should be maintained. Accurate information, there is no lie factor. And consistency, there is no data ink parties to be maintained, and storytelling that should be in proper order. So what are the different real world examples impacts the data visualization? So when we are seeing the COVID-19, so one university, Hopkins University, developed one dashboard.
Right.
So I want to show the real time ones.
Yes, it is visible.
So here you can see the COVID-19 health map.
Yes.
So here we are observe the India. So how it will be useful for user? You can see. So in the month of January 2020, there is no COVID cases. In different areas, it will be there. And every day is going on. The number of cases are increasing. And that will be shown in the health map. It is one type of map which is available in the data visualization area. I think you are observed the bubbles are increasing. The bubble sizes are increasing. So this much of impact. So finally, the India is to be like this. So this is another dashboard which is generated. Which is generated. So you can select India. So for better understanding. So gender wise, residence wise, education wise, how it will be generated. How it will be propagated in the COVID time. So like that. So NASA climate change visualization is there, and real-time air traffic, it is very interesting. You can see now. You can see the current situation. In current situation, the flight radar graph, this is. So how many airplanes are moving from where to where. You can choose anyone and see the details also. So sometimes it will be useful for hacking. Who are doing the hacking area, they are using this website in one way. This website is very good for know the details of the flight. At the same time, it is a very confidential information. It will be taken to anyone. The flight information is there.
Right.
So that is the sometimes problems are also created. So okay. Sir, we are telling data visualization is great and good, but anyone have the success stories to use this one? Yes, definitely. The Google have the one success story. So Google flu trends estimates. Using of this one, so many countries are benefited. Using of this data analysis and the data visualization. So many countries are benefited. So how the flu is propagated from year to year, and in every month date wise data visualization will be represented. So they can assume in the January, February, March, May, in the month of May in Brazil, the flu is high.
Right.
Flu is high. Depends upon this data visualization, they can understand. They will take care in the month of January, February to July. Maybe it's winter season, I think so. So they will take care about the things. So this is a one success story. Success story like that. So many organizations, so many companies, they have the success stories. Even Uber, we are thinking Uber is just a cab booking agency, but while they are performing the cab booking using of that data, they are making the planning of cabs in particular area in particular time using of data visualization. So I want to get more idea. I want to explore in the data visualization field. So what I can learn. So I want to give the small suggestions. It depends upon my experience. So better to take some online courses from anywhere. Coursera, EDX, Udemy, or NPTEL is very good if any course is available. And read the books. Nowadays, no one is reading the books. But I recommend one book. This is a father of data visualization, Edward. The challenges participation is good, but when we are participated in a good organization, then we are recognized.
Right.
The Kaggle and data visualization challenges will be happened every 6 months. They are announced the data visualization challenges. You can participate if you have won the challenge. You can get the badges. That badges are very recognizable by the industry. And attend the workshops or webinars like this. and collaborate with other persons who are excel in this data visualization. And for data visualization, the main thing is data source, data source, data set. Data
Yes.
source means data set. The data set is very, very important. If you are not able to create your own data set, no, don't worry, just you can download the ready-made data set which are available in the data.gov, Kaggle and World Bank. Like there's so many organizations they are giving. Recently the government of India decided, I think in corona time they are decided, they want to give the data, maybe the government data of the different departments, like not like a confidential information. So they want to give the data to the society for making of better data science and data visualization. So these are the references I am followed. So finally, you should be creative in the data visualization. You should be creative. You should be unique. So whatever way we are presenting the data to the user, that should be unique. Then only it will be impressive to the end user. And finally, it should be you only. So any questions? I think I am using the time in perfect.
Yes, sir, definitely. Thank you, sir. Sir explained the importance of data in today's era. Understanding the data is more important. Its processing, its meaning, its use, the tools, soft tools, and process were explained effectively. The data visualization importance in today's world as it show diagrams and easy to understand it. Quick visualization of data is effective for presentation. He also explained the data ink ratio concept, latest trends in data visualization. If anyone have any query, kindly unmute your mic and ask the questions. Does anyone have any questions regarding to the topic?
Madam, shall I proceed?
Yes, sir, definitely.
Thank you.
Thank you, sir.
Good afternoon to one and all present here.
Good
This
afternoon.
is Raj Kumar from VIT University Chennai. I have been assigned as a session chair, and they told to take maximum of 10 minutes time to extract the essence of this session. Thank you, Dr. Purva Madam, for introducing me here at the start of this session.
Thank you.
Before proceed with my role, as I already told session chair in this conference, first of all, I would like to say thanks to the organizer, Professor Dr. L. Revatkar sir, and other organizing committee members of this conference on technological advancement in computer science, artificial intelligence, machine learning, and data science. Hope this conference is providing a platform to share the knowledge in different recent trends in current scenarios, such as computer vision, machine learning, deep learning. Everything is important nowadays. Hope the next 2 days will be a great knowledge sharing session to all the participants who are involved in this conference. Actually, creating such a platform for the researchers and for showcasing the research is not an easy work. So it involves many more works, many more people were involved in it, such as from the scratch deciding the theme of the conference, panel discussions, keynote sessions, choosing the speakers, call for papers, and then scrutinizing and selecting the best papers for the presentation, and then choosing the session chairs, fixing the panels for paper presentations, managing, that is very, very important, managing the time, etc., etc. Many more people were involving in it. Really great applause to entire team of the conference. Also, I congratulate all the members of this conference who have supported directly and indirectly for making this conference a grand success and reaching this conference across the different parts of the country. With this note, let me come to my role. I have to finish my job.
Yes.
Uh, because I have, as I already told, I have given maximum of 10 minutes to brief the summary of this session. I would say thanks to our eminent speaker, Dr. M. Prasad, Associate Professor, Vishnu Engineering College for Women, who delivered the lecture on visualizing the future trends and innovations in data visualization. It's a very hot topic in the current scenario in the field of computer science and engineering. So first, let me just extract the essence of this lecture. It was started with the significance of data, why the data is important across various fields, the purpose why we come for this data visualization, and then it went through the relationship between data visualization and data science. And sir also make it more interactive videos to represent the different interactive pictures to represent different types of data visualization. That was I could remember by that time. Yeah, there is a proverb: a picture is a worth of 1,000 words. It's really true. How to choose, and then the session went through how to choose the data for correct type of application, such as geographical data and other data applications. And then the flow diagram was clearly explained, where everyone can able to understand what it is, why we go for this data visualization process. And then about the different characteristics, I guess the different principles of data visualization also discussed. And then how to make the meaningful comparison, with some examples, real-time examples have taken and explained. The chart characteristics. The chart should tells a story, and it should have graphical integrity, and should minimize graphical complexity, and so on. And then impact of choosing the scale in a graph. How the accuracy gets enhanced, how the accuracy gets reduced if we choose the scaling starting from 0, or if we choose a scaling starting from other than the 0 value. Those things are really helpful. And then data visualization techniques through a video, as I already told, and then through websites such as LinkedIn, and then COVID 3D COVID dashboards and all explained. But one point I had a small question, sir. If you hear, can you please
Sir is here.
about the 3D?
Yes,
I
sir.
guess, sir, you mentioned in 3D. Why the 3D? You said that the 3D is not more accurate way of data visualization.
Sir,
Can you please brief why the
yes, sir.
3D is? Because we can get the clearer details and finer details when you compare with the 2D visualization. And you said that that's not accurate. May I know why it is, sir?
When you are go to the 3D visualization, we have the more complex information to be present. So when we are presenting the complex information to the end user, if the end user is a very good person, we have the good knowledge, you can understand, no issue. Generally, the visualization will provide for who are not having the knowledge on the data. So
Okay.
by simply they can understand this is good and this is a bad, and in this area we have the good sales, in this area we have not the sales. So they have
Okay.
very simple clarity information they need. So 3D is not always good or not always bad. In as per this person, data visualization father person, he recommended 3D is not good for the simpler and clarity visualizations.
Okay. Shall I take it in this context is based on the application that we are choosing? We can go with 3D or 2D.
Yeah, application. So we can go with the data analysis of the user student performances. I have the different students. So when we are go to the student performances of the second year, so let's take the second year. Second year, I have the 4 sections. For every section, I have the students and their percentages, and section name is also there.
Okay.
One quality information, 2 quantity information. Suppose I am presented in a 3D, it's not understand easily. That's the thing.
Okay. Okay, sir. Thank you. Overall, the session was more informative. Thank you, sir, for sharing your expertise and knowledge with us. The entire session was so practical. It seems like a thought-provoking session to all of us. Hope all of you explored a lot from this session. There's no doubt in it. Thank you very much, Dr. Prasad. And last but not least, 2 minutes. 2 minutes. I wish all the committee members of this conference a grand success. With the small request to that, you can keep this in international level as a series in the next year, something like International Conference 1, Conference 2, and so on.
Definitely, sir.
Yeah,
Definitely.
yeah.
Definitely, you can call us also.
Yes, sir. Of
yes,
course, of course.
I also congratulate all the authors who are presenting their research papers in this conference. Thank you.
Thank you,
you.
sir. Your thoughtful
Thank you, sir.
and clear of depth to the conversation, engaging and fruitful discussion among the participants. Thank you for your appreciation toward our efforts, sir. Thank you so much. It is the wrap up of our first session, but before that, I would like to thank our resource person, Dr. M. Prasad, and moderator, Dr. S. Rajkumar. Your dedication to advancing knowledge is inspiring, and we are grateful for your contribution. I, Ms. Purva, take your leave and welcome Ms. Sharvari Ramteki to proceed further. Thank you, sir. Thank you so much.
Thank you, madam. Can I leave?
Yes, sir. Yes.
Shall I leave? Shall I leave, madam?
Yes, sir.
Thank you, Leeladhar sir. Thank you very much inviting me.
Welcome, sir. Welcome, sir.
Thank you.
सध्या बंदच राहू दे. Sharma sir, good afternoon. Sir, you are not audible.
Oh, good afternoon. Oh.
Good afternoon, sir.
Is that audible? No?
Yes, sir. Yes, sir. You are audible.
Okay.
Yeah.
Sir, am I audible?
Yeah, you are audible. Please start.
Yes, sir. Thank you, Purva ma'am. A very good afternoon to all the dignitaries, my colleagues, and the participants. I, Sharvari Ramteke from Department of Computer Science, extend a warm and hearty welcome to all on behalf of Dr. S.C. Gulani, Prerna College of Commerce, Science and Arts, in the second session of two-day interdisciplinary National Conference on Technological Advancement in Computer Science, Artificial Intelligence, Machine Learning, and Data Science. Now, I have the honor of introducing our resource person for this session, a person of outstanding personality, Dr. P.K. Sharma, Associate Professor, PG Department of Mathematics, and Chairperson, Dr. Ajit Maslekar, In Charge Principal, Adarsh Shikshan Prasarak Mandal. Thank you so much, sir, for your presence. Now, I would like to introduce our resource person, Dr. P.K. Sharma. Dr. Poonam Kumar Sharma is the Associate Professor in the PG Department of Mathematics, DAV College, Jalandhar. Sir has completed his PhD, Islamia University, New Delhi. Thesis synopsis, some relative relation modules of finite groups. His area of interest are modern algebra, journal topology, discrete mathematics, fuzzy topology, fuzzy algebra, intuinistic fuzzy mathematics. Sir, presently working as Associate Professor at Postgraduate Department of Mathematics, DAV College, Jalandhar, under Guru Nanak Dev University since 1994. Also work as a lecturer in mathematics in DAV College, Chandigarh, under Punjab University from 1993 to 1994. He is the member of Board of Studies in the Mathematics UG of Guru Nanak Dev University, Amritsar. He is the Dean Alumni Association of the DAV College, Jalandhar. He has completed major research project titled A Study of Intuinistic Fuzzy G Modules, sponsored by University Grant Commission, New Delhi. He had been organizing secretary of UGC-sponsored national conference, recent trained in discrete and fuzzy mathematics, held in DAV College. He has published more than 150 research papers in national and international journal and also published many books. Sir has been awarded Lifetime Achievement Award by VD Good Professional Association in the International Scientist Award on Engineering, Science and Medicine held at Salem, India. Also nominated in Who is in the World for 2015. It's a true honor to have someone with such an incredible personality with us today. And I'm sure everybody is excited to listen today's distinguished resource person. Now, I would like to introduce our moderator, Dr. Ajit Maslekar. Sir, currently working as an in-charge principal at Adarsh Shikshan Prasarak Mandal, KT Patil, College of Computer Science, Usmanabad. Sir has completed his PhD in the mathematics from RTM Nagpur University. Sir has participated 1 week interdisciplinary short-term course on research methodology in Bhai Kishan Rao Deshmukh Mahavidyalaya, Chakur District, Latur, affiliated to Swami Ramanand Tirth Marathwada University, Nanded. Also participate in district level Avishkar 2016 jointly for Usmanabad and B district organized by Avishkar Cell, Dr. B.A.M. University, Aurangabad and Adarsh Shikshan Prasarak Mandal, KT Patil College of Pharmacy, Usmanabad. Sir has awarded for the best principal among all the institutions of Adarsh Shiksha Prasarak Mandal, Usmanabad. Now, I would like to call our resource person, Dr. P.K. Sharma. Sir is going to motivate us on the topic on fuzzy mathematics and its importance in technology. Over to you, sir.
Thank you, Mr. Shirwari, if I'm pronouncing it correctly.
Yes, sir.
Yeah, okay. First of all, I would like to thank Professor Shirwari for introducing me in a very charming way. Secondly, I would like to thanks for Principal Dr. Niladhar for giving me opportunity to come and participate in this conference and deliver my talk. The topic of my talk is fuzzy mathematics and its application in technology. So let me give you my slides.
Sir, you are already on presenting mode. Start
Oh,
your PPT.
okay. Is my slide is visible?
Yes, sir. No, your slide is not visible, sir.
Oh, okay. Let me. Is my slide is visible now?
No, sir.
No. Okay.
Sir, you are on the presenting mode. Just open your PPT.
Yes. Let me know if my slide is visible.
No, sir, your slide is not visible. It is completely white background, actually.
Okay. So actually, I'm using this on Google Meet. Quite. Screen.
I'm gonna share it for you, sir.
So
Sir,
can you
share.
guide me? Can you guide me how to Put
Yes,
my
sir.
slides.
Yes, sir. Yes, sir. Sir, is my screen visible to you?
Yeah, your screen is visible.
You just have to click on this icon.
Which I can.
This one, sir. Fifth number. This upward arrow.
Upward. Okay,
Yeah.
yes, I clicked it.
And click on the entire share screen.
Entire screen.
Yes, sir. And then start your PPT. I'll stop sharing from my side, sir.
Okay.
Yes, sir. You are on the presenting mode. Just open your PPT.
First, I.
Yes, sir. Yes, sir.
Is my screen visible?
Yes, sir. Click on from beginning. Yes.
Okay.
Yes,
Okay.
sir. Yes,
Is
sir.
it visible?
Yes, sir.
Am I audible now?
Yes, sir. Yes, sir. You are audible.
Okay. Okay. Thank you. So, title of my talk is Fuzzy Mathematics and its importance in tokenomics. So, the content of the talk are as follows: a bit of history, fuzzy thinking, fuzzy sets and some examples, fuzzy boundaries, grip sets versus fuzzy sets, fuzzy set operations, fuzzy set representation, fuzzy relation, linguistic variables and edges, fuzzy application, and working of washing machine using fuzzy logic. Set theory. George Cantor in 1870 gave the concept of set theory, which is of great importance in mathematics. Actually, he defined fuzzy sets. Oh, sorry. He defined set as a collection of well-defined, distinguished object. So here he used two terms. One is well-defined, and second is distinguished or distinct elements, objects. So by well-defined, he means that given a rule with which we can determine whether an element or the object belongs to the collection or not, that should be well-defined, must be clear. If it is not clear, then that collection is not a set. And secondly, he defined the term, he used the term distinct objects. Distinct means the elements cannot be repeated. So if the elements is repeated, then we call it is a multi-set. So two terms are very, very important in the definition of set. That is well-defined and distinct objects. Okay. So using this, it has a various concept in set, in set theory, and nowadays we are using it quite often. So what important here is when the concept or the collection is not well defined. So what we call that collection is, for example, you have a collection of all intelligent students in your class. But for me, the objects are something different. For other, the objects may be different because for me, the objects are a person who is intelligent in mathematics is my objects. But for some others, the collection may be different because he may collect the objects who are students who are intelligent in computer science or in math, in physics or chemistry. So the collection is different for different rules because the objects, the rule is not well defined. Who is intelligent? cannot determine whether a person is intelligent or not. So it is not well-defined rule. So that's give rise to a fuzzy thinking. So the concept of set and the set theories are powerful concepts in mathematics. However, the principal notion underlying set theory that an element can exclusively either belongs to the set or not belongs to the set make it well nigh impossible to represent much of the human resource. That is, how one is to represent the notion like large profit, high pressure, tall man, moderate temperatures. So ordinary set theoretical representation will require the maintenance of a crisp differentiation in a very artificial way. So you, in artificial way, you can say this is high, this is low, this is quite low, but that is not possible in the other sense. So the fuzzy set theory was formulated by Professor Lofty-Zadeh at the University of California in 1965 to generalize the classical set theory. Zadeh was almost single-handedly responsible for the early development in this field. Of course, in set theory, or that means set theory, or classical set theory, a set X is in the universe of discourse and its element is denoted by small x. A crisp set A is defined as a characteristic function, chi A. It is defined as a mapping from x to two set value function 0, 1. That is, chi of Ax is 1 if x belongs to A or 0 otherwise. So it means in classical set theory, a subset is represented by a characteristic function. So there is one-one correspondence between a subset and a characteristic function. So given a subset, you have its characteristic function. And conversely, you have a characteristic function, there is a subset. That is called A. So corresponding to a subset A, you have a characteristic function, I of A. So its value is 1, or if element belongs to the collection, or 0 otherwise. So the set map X to a set of two elements. So in fuzzy set A of the universal set X is defined by a membership function, mu A. So mu A is a function from X to close interval 0, 1. That there can be many values between 0 and 1, where mu Ax is equal to 1 if X is totally inside A, and its value is 0 if X is totally outside A, and its value lies between 0 and 1 if X is partially inside A and partially outside A. This definition of set allows a continuum of possible choices. So you now have continuums of possible choices. For any element X of the universe X, the membership function mu X equal to the degree to which the element X of an element of the set belongs. This degree, a value between 0 and 1, represent the degree of membership and also called the membership values of the element X in the set, fuzzy set A. So fuzzy sets are different from your ordinary sets because here the membership values is given rather than characteristic values. So if a formal representation of fuzzy set is that it is represented by an element X by the ordered pair, that is an element X along with its membership function values mu Ax for every X belongs to X. So corresponding to every element of the universe, you have its characteristic, its membership values. Right? So fuzzy set is totally characterized by the membership function. So you can ignore the element because it is defined on the classical set X. So it is fuzzy set is generally related with the membership values. So the crisp definition and what sets and fuzzy sets. A crib set A can be defined as a set which consists of elements with either full or non-membership values at R in the set. So it is represented on the right side. So crib set is if the element is inside the set A, its value is 1, otherwise its value is 0. But a fuzzy set is characterized by a class of object with a continuum of grade of membership. It is characterized by the membership function. So it is given represented on the line by a triangle. So if the value is 1, that means the element is totally inside the fuzzy set. And if it is value is 0.1, 0.2, 0.7, 0.9, so it's well. It means it is partially inside or partially outside. So a fuzzy set is represented by the membership values. Here is one more example. Suppose you have a classical set X, a collection of all geometrical figures. Like we have this rhombus, circles, hexagon, square, triangle, right, octagon, and so on. So what can define is you are to define the crib set of circles. So you collect all those objects which look like a circle. So C is equal to, these are 3 objects represented, small circles and bigger circle and larger circles. But in fuzzy set, the circle set can be defined with all those objects whose membership values. So here first element is your hexagon. Its membership value is 0.1 because it's like look like to be around a circle, but its value is 0.1. But if you have a octagon, so its value is 0.3 because it's more like to be a circle. Or octagon, heptagon, and multi-polygon, so its value is increasing. Membership values when it reaches exactly the circle, so its membership value is 1. So all the circles will have membership value 1, whether it is a small circle or a bigger circle or very big circle. So in this way, you can represent the fuzzy set of circles in the second way. So fuzzy membership functions. So one of the key issues in all fuzzy set is how to determine the fuzzy membership functions. So this is the key idea. Then how to represent the membership functions. The membership function is fully defined the fuzzy sets because the fuzzy set totally depend upon this membership function. So a membership function provides a measure of degree of similarity of an element to the fuzzy set. Membership function can take any form, but there are some common examples that appear in real applications. So membership function can be either be chosen by the user arbitrarily, who is using the fuzzy set theory, he may use the membership function from its own. But he may also use based upon the user experience. So what problem he is tackling or what problem he is using. So according to that problem, he may use the membership function. So membership function chosen by 2 users could be different depending on their experience, perspectives, or the problem they are handling. Or the membership can be designed using machine learning methods, that is in artificial manners, neural network, genetic algorithm, etc. There are different shapes of membership functions: triangular, trapezoidal, piecewise linear, Gaussian, bell-shaped, etc. So trapezoidal membership function is given on the or represented on the right side by so its value is represented if x is less than alpha, its value is 0. Value is x minus alpha upon x beta minus alpha, and if x lies between beta and gamma, its value is 1, and if x lies between gamma and delta, its value is delta minus x upon delta minus gamma, and if x is greater than delta, it's value is 0. Similarly, in triangular membership function, when beta and gamma are coincide, you will have triangular membership function. Other form of membership function is Gaussian membership function. So its value membership function is given by exponential of minus 1 by 2 to x minus, where c is the center, s is the width, and m is the fuzzification factor. So its shape is given like this. So for different values of c, m, and s, you will have different shapes of fuzzy sets. Membership function. So one of the important examples for understanding the differentiation between crib set and fuzzy set is the classical example of tall man. The element of fuzzy sets, tall men, are tall men, but their degree of membership depends on their height. Suppose you are having a list of persons in your class with various heights, ranging from 152 to 208. So, if you are asked to declare that a person whose height is more than 180 centimeter, he is high, he is tall. But if his height is less than 180, he is not tall, he is short. So in classical set theory, so you have a differentiation that a person whose height is more than 180 is a tall, otherwise he is not tall, that is a short. So there is a distinction between, there is a boundary that one side you have a tall, other side you have a not tall person, that is short person. But in fuzzy set theory, you may give a different membership values to the person according to their heights. So if a person height is 181 centimeter, right, he may be considered as tall with some other membership value. But if his membership value is 198, 205, 208, then he is considered membership value is larger than this. But if the membership value is 179, is not, as the rule says, it's not, but its membership value you may give 0.9, but its value is membership value is 0.9, but it in the other sense that is short, but it simultaneously is tall. So the fuzzy set membership value, according to membership value, you can consider the tall set as it is given in the second figure. So the x-axis represents the person according to the heights, and y-axis represents the membership value. So according to various membership values, you can represent the fuzzy sets. So there is another way. Suppose you can add to crib set that there is a 3 category. A person whose height is more than 180, that is tall. But if its height is lie between 170 and 180, he is considered an average person. But if its height is less than 170, he is considered as short. But still, there are possibilities that there are many persons who are considered as tall simultaneously as average tall, and average short. So that is given in the second figure as a first set. So it is in the first figure it is represented liquid differentiation, but in the second diagram it is given in the fuzzy set. That a person whose height is say 184 is considered in the average, but simultaneously is considered as a tall with low values. As a low membership value is as a tall person is small, but as an average person his membership value is large, right? So there is a distinction between the crypt set and the fuzzy sets. So here is one more example is given. The most obvious limiting features of vibrant set that can be seen clearly is the diagram is that they are mutually exclusive. So in crypt set, the objects are mutually exclusive. For example, you have a characterize the temperatures. So if the temperature is lie between -10 and 0 degree, it's called cold. And if temperature is between 0 and 10 degree, it is cool. But if temperature is between 10 to 20, it is warm. And if the temperature is 20 to 30 degrees, it's called cold. So there is a fixed distinction between the various temperatures, right? But in fuzzy sets, sorry, there are situations where you can have at simultaneously it is cold as well as cool. Similarly, you can have warm and cool, cold and warm. So next is the crypt set operation. As you know, in set theory, you are given two sets. You can have the union, their intersection. You can have complementation, subset rotation, equalities. So coding, how we have. So the same can be done with the help of characteristic function. So if you apply the rules of set theory, the characteristic of function of the union of two set A, B is the maximum of the characteristic value of x in A and x in B. Intersection is the minimum of this, and complement values of x is 1 minus chi of Ax. And the other set theoretical constructions are essentials are crypt set inclusion. If A is subset of B, that is if and only for every x belongs to A, we have chi of Ax equal to 1 implies chi of Bx equal to 1. If A equal to B, if and only for every x, chi of Ax equal to chi of Bx. But in fuzzy set notation, the characteristic function of x in A and membership value of x in B. And in complementation, the element of membership value of x in not in A is 1 minus membership value of x in A. So in fuzzy set theoretical, we have if A is subset of B, if and only if membership value of x is less than equal to membership value of x in B for every x, and equal to B if and only if membership value of Ax in A is equal to membership value of x in B. So again, we can encrypt set if you are suppose you are given the set A and B, and you have to write down the union of two set. So if this is the set A and this is the set B, then A union B is the whole set. But in fuzzy set, if this is the set A on the right side, it is represented membership value by red, and the set B is the represented by pink. Then the membership value of A union B is represented by this, right? The upper planes. Similarly, if you have the ellipse and rotation of intersection of two sets, suppose this is the set A and this is the set B, and if you take the intersection of A and B, it is present on the left side, but in the right side, it is represented by this bordered area, right? So if you are to represent the complement of a crypt set, it is represented on the left side. If this is the set value, the membership value is 1, right? Here its membership value is 0, and conversely. So in crypt set, fuzzy set, it is represented on the right side. If this is the fuzzy set A, so this will be the complement of fuzzy set, right? Another example of fuzzy sets is suppose A is the collection of all x which are near to integers, and B is the set of all numbers which are close to 2. So its membership values is given in for the set A is as mu Ax, it will present on the first diagrams. So an integer which is near to an x, which is near to an integer, because x is integer, so its value is 1. But if x is your 0.9, 0.8, 0.7, or 1.1, 1.2, its value is less than 1, right? So it is represented by this diagram. So these all are fuzzy set. So A is a fuzzy set, is representation is given membership value. And this is set B, whose membership value is an integer which is close to 2. So an integer which is equal to 2, its membership value is 1. But if it is 1.9, 1.98, 2.1, so its membership value is less than 1. Right? So accordingly, if A is the set this, B is the set this, you have to define A union B, or A intersection B, or A complement. So it is given like this. It is represented. So the membership value, which is represented by the green, it is represent the membership value for union of two sets, and the membership values which is represented by yellow, it gives the membership function for A intersection B. And if the fuzzy set is represented by red, then membership value for its complement is represented by green. Right? So what difference is in set theory and the fuzzy set theory is that the law of excluded middle do not hold in fuzzy set theory. What is that lies? That means in set theory, if you take a set and its complement and take their intersection, this is always empty. But in case of fuzzy set, the intersection of A and its complement is never an empty set. That means there are certain elements whose membership value is not 0. Right? So the law of excluded middles do not hold in fuzzy set. Since the minimum of membership value of x and 1 minus mu x is never 0. Thus, the set of numbers close to 2 and the set of numbers which are not close to 2 is never empty set. Similarly, the law of exclusion, contradiction do not hold in fuzzy set. That means if you take a set A and its complement, then union is x in set theory, but it is not equal to x. That is the maximum of membership value of x, and 1 minus qax is never equal. Thus, the set of numbers close to 2 or the set of numbers not close to 2 is not the whole set. So, fuzzy relations. Next topic is the fuzzy relations. So, in these relations, we will find or list the ordered pair with the membership values, the matrix representation, and then the composition of fuzzy relation. As in case of relation, ordered relation, that is in field theory, fuzzy set theory, we have relations. Suppose you have already sets A and B. So what is a relation or a binary relation? Is a set which is a subset of A cross B. That is any so it's a relation is an ordered pair of elements whose one element is A, other element is B. Element A belongs to the set A, B belongs to the set B. So any subset of A cross B is a relation from A to B. So suppose the element of A are related. A1 is related to B3, A2 is related to your B5. Similarly, other elements are related. That is given here. So this is a relations. So what is the matrix representation of a relation is? That means if you are having set X and Y with element X1, X2, Xn, Y1, Y1, and Rj, small rj is the relations between Xi and Yi. So it gives the membership values or the characteristic value. If you are dealing with the relations, then it is membership values or characteristic value. If you are dealing with the fuzzy relation, then it is a membership values. So if R is the matrix of relations from X to Y, then it is M by N matrix, right? Because so it is an ordered pair Xi Yj. Xi belongs to your capital X, Yj belongs to capital Ca. So Rij is equal to your 1 value if there is an element Xi which is related with Yj in the relation, its value is 1. Otherwise, its value is 0. Right? For example, suppose you have this relation from A to B. So, what is the matrix representation of the relation R is? It is value is 1. Because A1 is related with your B1. A1 is related with B1. But A1 is not related with B2. So, its value is 0. A1 is related with A3, B3. So it means its value is 1. Again, A1 is not related with B3 and B4, B4 and B5. So value is 0, 0. So accordingly, we can give the values to the relations. So it is a matrix of relations. In Cripps relations, its value is 1. Suppose this is the set X, this is set Y. 1 is related with B, 2 is related with A as well as B. So its relation matrix will be 0, 1, 1, 1. Because 1 is related with 1 is not related with A. So what 1 is related with B, its value 1. Okay. So fuzzy relations R is a 2D membership function. So what is fuzzy relation is? It is it's a ordered pair XY, and then the membership value of the ordered pair in the relations. So how to calculate the membership function value of the ordered pair? So this is important. For example, suppose you are having set X as X1, X2, X3, Y1, Y2. So the set is fuzzy set with membership value X1 is 0.2, 0.5, 1, and then set B is membership value of Y1 is 0.3, Y2 is your 0.9. So membership value of XY, it is the minimum of membership value of X in A and membership value of Y in B. So accordingly, you can define the matrix of the fuzzy relation as R is the matrix. So in the column wise, you write the element x1, y1, x1, x2, x3. On the right column side, we will find y1, y2. So if x1 is related with y1, so you can calculate the membership value of x1 and y1 as the minimum of these two. So from the minimum of x1 and y1, you can calculate it is 0.2 and it is 0.3. Take the minimum of these two. That is 0.2. Okay. So this is again a Cripps relation. As I already told you that you can now define the matrix representation of union of two relations, intersection of two relations, and complementation of two relations, and containment. Right? So properties of Cripps relations. The properties of commutativity, associativity, idempotency, and distributivity all hold in Cripps relation. The De Morgan law and the excluded middle law also hold in Cripps, but they do not hold in particularly the law of excluded middle hold in fuzzy relation. But however, properties, commutativity, associativity, idempotency, distributivity, they are holding fuzzy relations. So, composition of Cripps relation, as you say, if there is a relation from X to Y, there is another relation from Y to Z. Can we have a relation from X to Z? Yes, you can have a relation, and that is called the fuzzy composition of two relations R and S. So it is a relation whose membership value in the characteristic function value of I of t xz equal to the maximum characteristic value of xy and characteristic value minimum of characteristic value of y and z, where y is an element belonging to y. So in between, if x is related with y and y is related with z, then you can calculate the membership value of or the characteristic value of xz, like by this rule. For example, let me have this example. Composition relations. Suppose we have the set X with the elements x1, x2, x3, the set Y with the element y1, y2, y3, y4, and the set Z with z1, z2. So this is the relations R. x1 is related with y3, x2 is related with y4. Matrix R is represented by, because it's a relation from x to y. So we write x. So it is 1, 0, 0, 1, 0, 0, 1. And relation, your S is given as this relation between y and z, right? This is the Phillips relation. So that when we take the composite of this, so the membership value of x1 z will be 0. The rest will follow it similarly, right? So I told you this property do not hold in fuzzy relations. So we have another example of relations. A fuzzy relation R in 2D is a membership function written by this. For example, you have a membership value relation from x to y, fuzzy relations. Its value is 1 if the difference between x and y is 0. And membership value of x relation between x and y is 0.8 if the difference between x and y is 1. If the difference is 2, then it's 0.3. Otherwise, it is 0. So if this is the membership values of the different ordered pairs between x and y in the fuzzy relations, then accordingly you can draw its matrix representation by like this. Now, how to write this? I will tell you in this example. Yes. Suppose this is the relation R and this is the relation S. First, what we to write the element of composition of the relation R of S, R and S composition. You just write the element 1, 2, 3, this way, row wise. This is column wise, and alpha, beta, gamma on right. Then you write in the upper row as the membership values of A, B, C, D corresponding to 1. And then according to the column in S, you write the first element. And then take the minimum of these two values. Right? So this is the, then the minimum of these two is 0.1, minimum of these two is 0.2, minimum of this is 0.0, and 0.10 is 0.4. Then you take the maximum of all these values. So this will give you this value. But in alpha 1 and alpha, right? So accordingly you can find out the membership values of other values. So there is another relations that is called max product composition. Instead of taking the minimum here, you can take the product here. That is called max product composition. This is only the difference between these two. So this is another illustrative example is given. Just you have to take multiply here, not to take the minimum here, right? Another example which is right here is as an application is a certain types of virus attacks cell of in human bodies. The infected cell can be visualized using a special microscope. So this is the medical examples of composition of two functions. The microscope generate digital images that medical doctors can analyze and identify the infected cell. The virus causes the infected cell to have a black spot within a darker gray region. A digital image process can be applied to the image. The processes generate two variables. The first variable P is related to the black spot quantity, black pixel, and the second variable S is related to the shape of the black spot. That is, if they are circular or elliptic. In these images, it is often difficult to actually count the number of black pixels or to identify a perfect circular cluster of pixels, as both these variables must be estimated in a linguistic way. An infected cell show black spot with different shape in microscope graph. Suppose that we have two fuzzy sets P, which represent the number of black pixel. Example, none with black pixel. C1, a few black pixel. C2, a lot of black pixel. C3, and S, which represent the shape of the black pixel cluster. Example, S1 is an ellipse and S2 a circle. Suppose we have the set P, which is represented by C1 as membership values. 0.1, that is a black pixel with membership values 0.1, and and membership value C2 is 0.5, C3 is 10, and similarly for S1 and S2. Now we want to find the relation between the quantity of black pixel and in the virus and the shape of the black pixel cluster. Using Cartesian product between P and S, that will give you the relationship R from P to S by using this. Now suppose another microscope image is taken, the number of black pixel is slightly different. Let the new pixel quantity represented by a fuzzy set P dash with different membership values. So using max minimum composition with the relation R will yield a new value for the fuzzy set of pixel cluster shape that are associated with the new black pixel quantity. So S dash will be P dash of R. So you take the composition as P dash and R, its value is 0.3 and 0.8. So it means using different fuzzy sets, you can have the different relationship. Now another important topic here is linguistic variable. Now at the root of the fuzzy set lies the idea of linguistic variables. The linguistic variable is a fuzzy variable. For example, the statement Ram is tall implies that linguistic variable Ram takes the linguistic value tall. In fuzzy expert system, linguistic variables are used in fuzzy rules. For example, if wind is strong, then sailing is good. If project duration is long, then completion risk is high. If speed is slow, then stopping distance is short. So linguistic variables and heads. The range of possible values of linguistic variable represent the universe of discourse of that variable. For example, the universe of discourse of linguistic variable speed might have the range between 0 and 220 km per hour and may include such fuzzy subset, a very slow, medium, fast, and very fast. So these are the linguistic variables used in terms of speeds. A linguistic variable carries with this concept of fuzzy set quantifier that is called hedges. Hedges are terms that modify the shape of the fuzzy set. So, for example, it includes the adverbs such as very, somewhat, quite, more, or less, or slightly. So these are the hedges and linguistic variable which is commonly used in our day-to-day lives. So accordingly, your fuzzy sets, and hence the membership function is affected by these terms. So it is so the same problem which we have, that a person is tall, average tall, short, can be differentiated between by using different linguistic variable. That is, a man is short, very short, tall, very tall, average. According to that, the fuzzy set values is affected. So, linguistic variable enhances the membership function is affected. Suppose if the edges we use as a leader, the membership values is affected. Then VOX is power 1 by 3, 1.3. If it is slightly, the membership value is VOX to power 1 by 1.7. If it is very, so you can take raised to power 2. Extremely, you can raise to power 3. Accordingly, the graphical representation will be changing, right? So if you use another variables, very, you can use power 4. More or less, you can take power as under root and so on. So accordingly, the fuzzy membership values are changing. Okay. The term fuzzy logic. Why fuzzy? As I said, the term is concrete, immediate, and descriptive. We all know what it means. However, many people were repelled by the word fuzzy because it is usually used in negative sense. Why logic? Fuzziness rests on fuzzy set theory, and fuzzy logic is just a small part of that theory. The term fuzzy logic is used in two senses. In narrow sense, fuzzy logic is a branch of fuzzy set theory which deal or as a logical system do with the representation and inference from knowledge. Fuzzy logic, unlike other logic systems, deal with imprecise or uncertain knowledge. In this narrow and perhaps correct sense, fuzzy logic is just one of the branch of fuzzy set theory. So in the broader sense, fuzzy logic synonymously with fuzzy set theory. How fuzzy set logic is used in math? Fuzzy mathematics. In number set, you can use fuzzy mathematics number as almost 5. It is not exactly 5, right? It's almost 5. Or more than 50, less than 50. In geometry, fuzzy geometry, it's almost straight line. The line may not be straight, it means almost straight. In fuzzy calculus, you may use it as not quite a parabola. The shape is not a parabola, it's quite like a parabola. In fuzzy algebra, it is based on fuzzy relations. In graph theory, it is based on fuzzy points. The shape is accordingly because of its fuzzy values. So, what important is for the use of fuzzy set theory is the fuzzification and differentiation. Fuzzification is to transfer the crisp input into fuzzy subsets. Defuzzification is the fuzzy subset to real numbers. That is the reverse of the fuzzification. So important rule used is fuzzy system is the operation. I said you are having crisp input and then fuzzification is done. That is, we give the fuzzy values to the inputs, and so we have a fuzzy input. Then fuzzy input is we apply fuzzy rules. So rule evaluation is done according to the rule evaluation, that is minimum, maximum, union, intersection. So all various rules are used for getting fuzzy outputs. So again, fuzzy output, we fuzzify the fuzzy output, we get crisp input output, right? So this is the basic rule using fuzzy system. Simple example of fuzzy logic is the controlling a fan. Conventional method is that if temperature is more than X degree, run fast, otherwise stop. In fuzzy system, you can have, if the temperature is hot, you can design your machine that if in such a way that if temperature is hot, then the machine run fast at full speed, or your fan will be running at full speed. If the temperature is warm, the fan will run at a moderate speed. If the temperature is comfortable, maintain the fan speed. the temperature is cool, slow the fan. The temperature is cold, then stop the fan. So you can give in between various stages between temperature, according to the temperature, whether the fan will run at a full speed or at a moderate speed or at comfortable speed or even slow speed or stop at all, right? So classical concepts versus fuzzy concepts. In classical concepts, you have Boolean logic. That is yes or no. Yes or no concept. Hello. Yes. Fuzzy concept, you have fuzzy logic.
Yes.
Okay. Remind me 5 minutes before. Okay. So I will complete my talk accordingly. Do you hear me?
Yes, sir.
Okay. Remind me 5 minutes before. Okay.
Okay, sir.
Okay. So in classical set, we have no partial membership values. But in fuzzy concept, you have partial membership values are allowed. That is, in fuzzy, in classical, yeah, either the member belongs to the set or not. But in partial fuzzy set, you have simultaneously the member belongs to the set or not. So in classical set, sharp boundaries of membership value is given. That is either you have 1 or 0, right? But in fuzzy concept, smooth boundary of membership value is given between that range from 0 to 1. So in classical set, you have no uncertainty. In fuzzy set, you have uncertainty is allowed. In classical set, we have discrete or continuous variable. In linguistic variables, in classical fuzzy set, we have linguistic variables. In classical set, we have limited application to real world because of its idealism. But in fuzzy set, countless application of to the real world problem because it can deal with non-linear and ill-understood problems. So, as an application to fuzzy sets, the theory of fuzzy sets and fuzzy logic has been applied to problem in variety of fields. For example, in pattern recognition. So you create a pattern of different problems and then analyzing those pattern and then finding the best one, right? Then decision problem. Decision. If you have to make a decision, you have to make use of fuzzy rules, right? Data mining, information retrieval, medicine, law, taxonomy, topology, linguistic, automata theory, game theory, etc. And more recently, fuzzy machines have been developed, including automatic trains control, tunnel digging machine, home appliances, washing machine, air conditions, etc. Fuzzy classification. The classification is described by fuzzy if-then rules. Mostly in fuzzy set, we are designing the problem by if-then rule. We use if-then. An example of fuzzy classification rule for two-dimensional feature species. That means if you are having two inputs, x1 and x2, then we have R1 if x1 is small and x2 is very large. Then the element x1, x2 will belongs to the class C1. So this is the rule R1. That is, if x1 is small and x2 is very large, then the element x ordered pair x1, x2 that belongs to the class C1. And the rule 2 is if x1 is large and x2 is small, then the element x1, x2 belongs to the class C2. The rule is R3. If x1 is small and x2 is large, then the ordered pair element x1, x2 belongs to class C3. And our rule 4 is if x1 is very small and x2 is very large, then the ordered pair element x1, x2 belongs to the class C4. So where R1, Ri is the ith classification, and CK indicate the output. Class X1 and X2 are the features very small, large, and very large, are linguistic variable terms characterized by appropriate membership function. Inference of fuzzy rules based classifier. For simplicity, let the rule base contain 9 fuzzy if rules and have two input x1 and x2. So here we have 9 rules having if the input is 1 is A1, if the input 1 is A1 and the input 2 is B1, then the output is C1. Rule 2, rule 3, rule 4, so on. Rule 9 are defined. So accordingly, if your input 1 is your X node and the input 2 is your Y node, then you can create output as in C. C is any one of your C1, C2, C3, C9, right? So the firing level of the rules denoted by alpha is where I vary from 1 to 9 are computed by the following rules. So alpha 1 is the minimum of A1 X node and B1 Y node. Accordingly, you can have the values of alpha is for I equal to 1 to 9. If several fuzzy rules have same consequences class, then their firing strength have to be combined. Usually, the OR operation is used. The individual rule output are computed by these. C1 is alpha 1 or alpha 5 is the maximum of alpha 1 and alpha 5. And so, similarly, C2 is alpha 2 and so on. So, overall classifier output is selected by C as the maximum of C1, C2, C3, C8. So, this is the geometrical diagrams of various stages having two input X and Y, right? So, if X output lie in A1 or A2, A3, similarly Y lie between B1, B2, B3. Accordingly, we are having AND rules. So, it will give you the value alpha 1. It will give you C1. So, this is the output class C, right? Since each input feature is associated with 9 membership, the input shape is partitioned into 9 fuzzy subspaces, each of which is governed by the fuzzy if-then rules. So accordingly, you can have 9 outputs between C1, C2, C3, right? So by different values of A1, A2, A3, and B1, B2. So these are the diagrams. So to conclude my talk with an example of how the fuzzy rule is used in washing machine. Here I am explaining how the washing machine works when there is only 2 input. I am taking just 2 input because there may be more than 2 inputs because of the washing machine we are using here. For purpose of simplicity, I am using only 2 input. Right? The input I am using is the dirtiness of the clothes and the type of dirts. There may be some other inputs you may have. For simplicity, because of the complexity of the problem to understand, I am using only 2 inputs. So I am using linguistic input as type of dirts and dirtiness of the clothes, right? So accordingly, so I am giving 2 inputs, the type of dirt and dirtiness of the clothes. Above figures show that the basic approach to the problem. The fuzzy controller take 2 inputs as stated for the simplification process, the information and output as the washing time. So now I'm putting my clothes to wash, and there are 2 inputs type of dirtness, that is whether your dirtness is grade 3 type, or it's hard in nature, or it's oily, or different type of dirtiness you are having of clothes. And then the nature of the cloth, right? Types of the clothes is your silky, cotton, like that, right? So the process of information is that output is the wash time. So once you put your clothes in the washing machine and you are eager to know at what time I can take my clothes washed, right? So the output is the how long it will take to wash the clothes. How to get these two input out as firstly, how to get these two input can be left to the sensor. So firstly, your type of dirtiness and the dirtiness of the clothes is determined by the sensors. That is optical or electrical or any other types. Anyway, the two stages points need a bit of introduction. Which form? The degree of dirtiness is determined by the transparency of the wash time. So first time, because we have to give the different values, fuzzy values to the types of dirtiness. So first, it will you have to determine what fuzzy set values you will give to the types of ducts, different types of ducts. So degree of ducts is determined by the transparency of the wash time. So if the your transparency of the wash ductness take longer time, so you give the membership value to that type of ductness 0.9. If it is takes small value, you can give different values. So the director the close less transparency the particles. So according to the time taken by the different type of dirtiness, you can give the membership values to the type of dirts. Similarly, you can give the fuzzy values to the different type of dirtiness of the clothes, right? So accordingly, so once you have given the two input values, fuzzy values to the two different types of inputs, accordingly then you can choose your fuzzification rule or fuzzy arithmetics or fuzzy rules are computed. Minimum, maximum operations are applied, fuzzy rules are applied. Accordingly, you will have fuzzy output. So from that fuzzy output, we make use of defuzzification process. That is, from that fuzzy output, you will have fuzzy or rather fixed input as your fuzzy times, right? So in this way, you can give if bring to the machine to what output you will fuzzy values. I mean to say to decide whether because the degree of dirtiness whereas the type of dirtiness, the quantity of dirt, greasy cloth, for example, take longer times for water transparency to reach transparency because greasy is less soluble in water. Thus, a fairly straightforward sensor system can provide you the necessary input for the fuzzy controller. About the setup line, before the detail of the fuzzy controllers are dealt with, the range of possible values of input and output variables are determined. These, in fuzzy language, are the membership function used to map the real world measurement value of the fuzzy values so that the operation can be applied. Figure 2, which is this is figure 1, because we give the membership values to the type of dot test, and figure 2 is the membership values for the type of dots. Right? Figure 2 shows the level of input and output variables and their associated membership functions. Value of the input variables, the degree of dots and the type of dots are normalized from 1 to 100 over the domain of optical sensor. The decision which the fuzzy controller make is derived from the rules, which are stored in the database. These are stored in the set of rules Basically, the rules are if-then statements that are intuitive and easy to understand, since they are nothing but common English statement. Rules used here are derived from common sense, data taken from typical home use, and experimentation in a controlled environment. The set of rules used here is derived from the output are this. The set of rules used here is to drive the output as if the dirtiness of cloth is large and the type of dirt is greasy, then the washing time is very low. If the dirtiness of cloth is medium and the type of dirt is greasy, then the wash time is long. Similarly, we have 9 rules, right? So according to these rules, you can return one, the machine can return one, that these rules have different values, right? So when all are combined together, it gives you the washing time. So summary is, by the use of fuzzy logic control, we have been able to obtain a wash time for different type of dots and different degree of dirt. The conventional method required the human interruption to decide what should be the wash time for different clothes. In other words, this situation analyze ability has been incorporated in the machine, which make the machine much more automatic and represent the decision-taking power of the new arrangement. Though the analysis of this matter is very crude, but this clearly depicts the advantage of adding fuzzy logic controller in the conventional washing machine. So this is all about my talk.
Thank you so much, sir. It was wonderful and informative session. Sir explained crisp set and fuzzy sets in the easiest way. Sir also explained fuzzy sets by Tallman example. Sir also explained difference of set theory and fuzzy theory. Sir, firstly, it seemed difficult to understand, but as you explain it very well using diagrammatic representation and household example, we got a clear idea about fuzzy mathematics and its important in technological advancement.
Okay, so any query if you want to.
If anybody have any question regarding the session, they can ask.
Okay.
Okay. Thank you so much, sir.
Okay. Thank you, sir.
Now moving further. Now
Okay, may I leave now?
Yes, sir.
Can I leave?
No, sir. There is a moderator.
Okay.
Ajit Maslekar, sir.
Okay. Yes.
Now I would like to request this session moderator, Dr. Ajit Maslekar, sir, for enlightening the session. Over to you, sir.
Hello, madam. I am audible.
Yes, sir. Yes, sir. You
Yes.
are audible.
Yes. Now, good afternoon to all of you. And first of all, I am very much thankful to all the respected management of especially the principal of Revaskar sir, for giving me an opportunity to participate in a conference. Already, I am in a traveling, madam. So that's why I will end my session within 5 minutes,
Okay,
because
sir.
here is a heavy rain. Yes.
Okay.
Already, Dr. P.K. Sharma sir explained the importance of the fuzzy mathematics in technology.
Yes.
The sir already told the difference between the fuzzy sets, fuzzy logic, and all the set theory in a fuzzy. I will just told the applications regarding the fuzzy sets, like it is used in various sectors, like the aerospace, that is the satellite attitude control, intelligent highway system, business, that is the decision making system, electronics, that is the already sir told that is in a washing machine time or the microwave timing settings, and the finance sector, that is the stock market financial management and the predictions of the various stocks, etc., like the medical diagnosis in a medical field, and the in a industrial sector it is also important, like the water purification in a plant control. In various sectors we can use the fuzzy logics in fuzzy mathematics and the fuzzy sets in our day-to-day various sectors. So I am very much once again thankful to the all the managements of the Prerna College and Revatkar sir, and especially the PK Sharma sirs, who already gave the more than so much regarding the fuzzy mathematics. Thank you, madam. Hello.
Thank you so much, sir. Thank you so much, sir,
Oh, thank you,
for,
thank you, thank you. Yes, 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 yes.
for
Okay, okay.
sharing
Thank you, madam.
today's
Yes, okay.
session.
Yes,
Thank you
okay.
so
Thank
much, Honorable Resource Person PK Sharma
yes.
sir, Dr. PK Sharma sir, and our moderator Dr. Ajit Maslekar sir. Hope you
Yes.
all gain lots of knowledge for this session. Now, with the permission of Chair, I, Sharvita Ramteke, declare first day of conference is over. Now, we will meet tomorrow actually, at 9:30 a.m. sharp. Kindly stay with us. Thank you. Have a nice day.
Thank you, sir.
Thank you so much.
Thank you to
Yes, sir. Thank you.
Thank you, sir.
Thank you, sir.
बियर बनाने की